So we carried the same topic which we did yesterday, gravitation. Last question क्या लिया था मैंने? What is the last question I took? A rod. Clear हो गया था वो? Now let's take the next question. Six. Question number 6. It says mass m is uniformly distributed along a wire of length 2L. A particle of mass m0 is at a point that is distance r above the center on its perpendicular bisector. In the question yesterday, we had taken a mass along the rod, generally called an axial point, along the axis, axial point. This is on the perpendicular bisector. So we have to find the gravitational force on that small mass. Try करिए. समझ गया. If three balls obviously kept in line. Have you understood the question? Should we start? Correct? Now let's first understand what is the logic of this point on a perpendicular bisector. That means with respect to this line, this is symmetrical. That means if I take an element here, I can simultaneously take an element here also. As I told you yesterday, that force is directly proportional to 1 by r square. So every element on the rod, the distance of that element from this point is a variable. And if I take this point, so this is r. If I take the point here, then this distance is r square plus l square. If I take a distance here, then it will be this distance square plus this distance square. So that means there is an importance of taking an element. Let's first identify why do we need to take an element, because the distance everywhere is a variable distance. Now suppose we decide to take this distance as x. So this element will be dx. If I wish to calculate the mass of this element dm, it will be similarly, I can take an element here also. Now if I connect them, just to show the direction of force, what will be the direction of force on this mass L? The force due to dm, I can call this force as df. Right? And maybe I can take this angle as theta. This will be symmetrically theta also. What do you think will be the value of df? It will be g dm m naught upon correct? You agree? What will be df net? Df cos theta, df cos theta. These components will cancel. So I'll be left with 2 df cos theta. Which means this will be 2 times g by into m naught into dm. Dm will be into cos theta. Now what is the value of cos theta here? Base upon, so base is r and hypotenuse is so this will become the value of df net. लिखिए यहाँ तक. Clear is it? Absolutely clear. So finally, if you see this term, this is a constant, this is a constant, this is a constant, ये भी constant है, ये भी constant. So integrable quantity will be dx upon देखो ध्यान से. Which means what should be the limits of this function? X कहां से कहां vary कर रहा है? Should it be from this to this, or should it be from this point to this point? The center, because we have already taken a 2. Twice ले लिया ना आपने? ये 2 times लिया ना आपने? तो आपने simultaneously taken these two elements. That means if I'm taking an X this side, I have also taken an X. So that means when X varies from here to here, at the same time X is also varying from here to here. That means when X varies from 0 to L, automatically on the left hand side also X has varied from 0 to L. So my final integration will be, can you solve this integration? Try karo. What I've done is, आप करते रहो. There's some question there, you can keep solving. The question is that you can bring my video here directly. तो बच्चों को दिखाई दे जाएगा आराम से. Bring me on the screen. Now, this is a rod. जल्दी settle हो जाओ. The mass of the rod is m. The length of the rod is 2l. There is this mass small m which is kept at a bisector, perpendicular bisector of this rod. The question is, we have to find out the force which this rod exerts on m naught or m naught exerts on the rod, because according to gravitational attraction law, Newton's law, forces are equal and opposite. Now how do you start? Now since it's on a perpendicular bisector, I can take two elements on either side. Say I take an element at a distance x. The length of the element is dx on either side. So I take an x here and the element is dx. To find the gravitational force between m naught and this element, I need the mass of this element. How do you calculate the mass of the element? The total mass is m, the total length is 2l, so it will be m by 2l into dx. The force between this mass and this element, according to Newton's gravitational law, will be dF equals g dm, the mass of this element. I've taken this mass as dm, into m naught upon the square of this distance. Comes like this. Now since I've taken an element on the left hand side also, so the net force on this, because of these two elements, will be df. Net will be 2 df cos theta. So the net force is 2 df cos theta. The value of df, I can take it from here. The value of cos theta can be taken as base upon the hypotenuse. If you see in the entire terms, this term, and this term is a variable. So I need to integrate these terms. Could you solve it? देखिए, अब how do you solve this integration? R is a constant and x is a variable. Suppose I take x as r tan theta. Dx will be r sec square theta d theta. if I replace dx with r sec square theta d theta, नीचे हो जाएगा r square plus r square whole to the power. Can I do that? This will be r sec square theta d theta. I can take r square as common. So this will also become whole to the power. This becomes r sec square theta d theta upon कितना रह गया r cube so this becomes 1 by r square cos theta. Sec square, sec cube. So you're left with a sec. Sec becomes 1 by sec is cos. So cos theta. What is the integral of cos theta? ठीक है ना? Now, you've taken x as, so tan theta is x by r. कितना हो गया ये? x और ये? What is this? So what is sin theta? X upon, and what are the limits? X की limits क्या ली थी आपने? करिए substitute. Upper limit minus lower limit. Try करिए. हो गया? आ गया? अब जो रिमेनिंग टर्म्स हैं उनसे मल्टीप्लाई कर दो. 2g m0 m 2l r. Multiply this with the integral value of this. Now there is a student who's asking, sir, why did you take x as r tan theta? Can anyone reply? What was this? x. What was this? If I take this as theta, what will be this? What is this? And what is tan theta? What is tan theta? So there it is. दोबारा बताऊं. Explain again. You took this rod. You took this distance as x and this distance as. So if I take this as theta, what is this? Now what is tan theta in this? So what is tan theta? Understood. What is the final answer? After substituting, what is the final answer which comes? What is the option in here? A, B, C, D. The final option. B. Yes. B is the right option. Wait. This value kitna aaya? What is this value coming out to? 1 by r square L so if I multiply this with the terms which are marked with a correct sign, the correct option is B. That is how you approach this type of question. And this is a new thing which you have learned today, isn't it? How to integrate a function in such a situation. Okay? Wrap this off. Now there is a student who's asking me, so you said yesterday that centripetal acceleration is omega square r. We generally should avoid taking v square by r. You all want to know the answer? Try karte. We've all done pure rolling, right? Suppose a body is doing pure rolling. The velocity is v naught. Translational. The axis is passing through the center and the angular velocity is omega naught. Achha, what is the direction of angular velocity? How do we find the direction of angular velocity? Yesterday we were discussing angular velocity. How do you find the direction of angular velocity? Perpendicular to the plane of the motion. Hai na? Kaise pata? Achha, tell me what is the vector form of vector relation of v, r and omega? Like when you say v equals r omega, iska vector form kya hai? R cross v equals? Absolutely wrong. लिखिए. V is not r cross omega, instead V is omega cross r. This is the vector form of this equation. Right? इस case में V, omega and r, all three are mutually perpendicular to each other in a circular motion. V is tangential, r is radial. And why have I shown this with dotted lines is that the direction of angular velocity is along this pen. That is, it is perpendicular to the plane of v naught and r. ये ऐसे रहेगा. Now, I wanted to find the value of, or I wanted to locate the instantaneous center of rotation, which we discussed yesterday. Can you find the ICR, the instantaneous center of rotation for this point P? Can we find out the instantaneous center of rotation for point P if this body is doing pure rolling and the radius of this body is R? Try it out, please. The question is, what is the point about which this point P is moving in a circular motion? What is the center? Where is the center for this point P? Stuck up. So are we all stuck up? What is the definition of the center to how? What is the definition of ICR? A point about which this point P is undergoing circular motion. You agree? Right, great. Now to find out ICR, yesterday I told you that if you have the net velocity of that point, then the ICR will lie in a direction which is perpendicular to that net velocity. Yes, Arunima? What's your name? Arunima. Let's see. Can anybody tell me what is the net velocity of this point P? What is the magnitude of the net velocity? Okay. Yesterday, did I tell you something? That if you have to find the net velocity, what is step one? You allow the observer to sit here. If the observer is sitting here, this point will only do circular motion. And the direction of velocity in a circular motion is perpendicular, okay, tangential to, or I would say it is perpendicular to the distance joining these 2 points. ऐसे होगा ना? This will be r omega or r omega naught. Now the second step is, I told you to ask this observer to come and sit on ground. What happens then? Whatever velocity this point has, you have to add this velocity to this point. Yes or no? पहले तो ये clarity होना जरूरी है. ये बिल्कुल clear है? Absolutely. Since it is pure rolling, now when I say pure rolling, one is pure rolling, the other is uniform pure rolling. Any difference between these two? Or are they same? See, when I ask you a question, generally what happens is when you ask a question, you go into vacuum. Question, oh, teri. So you're actually looking at me, but you're not looking anywhere. See, when you look at someone, the expressions of the eyes tell the entire story. So when I look at you, there is a blank face. The second is, I'm trying to, एक और भी लुक होती है क्लास के अंदर, यह है खत्म, यह है कि क्वेश्चन ही समझ में नहीं आया सर. सेकंड लुक होती है, क्या कह रहे हो, व्हाट आर यू ट्राइंग टू से. थर्ड लुक होती है, दैट मीन्स यू आर थिंकिंग. आपको पता भी कैसी है? देयर इज कोल्ड, ठंड तो है ना, एंजॉय करो ना उसको. देयर इज अ सिचुएशन, एंजॉय इट. पहले मैंने बोला था अच्छा बनाना पड़ेगा. आई हैव टू टेल दिस एवरी डे. कीप स्माइलिंग. कितना मुश्किल काम है ना. नाउ आई सेड देयर इज अ टर्म कॉल्ड प्योर रोलिंग and there's a term called uniform pure rolling. Uniform pure rolling means the body is not accelerating. ACM is 0, alpha is 0, and the net velocity of this point with respect to ground is also 0. लिखिए, हमने रोटेशन कर लिया है. लिखिए, यूनिफॉर्म प्योर रोलिंग. कंडीशन for uniform pure rolling. Number 1, ACM is 0. Alpha is 0. The body is not accelerating at all. And VCM equals R omega. If the surface on which the body is rolling is stationary, please mention this. VCM is equal to R omega. ये बात समझ में आई जो मैंने बोला अभी? क्या? Explain. मैंने ऐसा क्यों बोला? Why did I say that VCM is R omega, but the surface below it has to be stationary? What happens if the surface itself is moving? Blank. Huh? Okay, no issues. Two situations. This surface is at rest. This is V naught. This is omega, the condition I'm actually talking about. The method which we use to find this velocity, we will use the same method to find this velocity. Let's start. First step, what do? The observer sits on the center. So how does it move? Only rotates. So this is. Then the observer comes and sits on the ground. So what do? So what is the net velocity of this point? It's V naught and the vector sum of R naught. If it is pure rolling, and I'm saying if it is uniform pure rolling, then in that case, V naught equals R omega naught. Now let's have a second situation. It is still doing pure, uniform pure rolling, but it is kept on a surface. This is say 3v naught. This is omega naught, and this velocity is v naught. This body is doing pure rolling. Now the situation will change. In this case, it was v naught equals r omega naught. In this case, it will not. Let's find out how. Now, if I don't consider this point, this surface, ये जो नीचे surface है, इसको मैं detach कर देता हूँ. What will be the velocity of this point, the lowermost point? 3v naught. And what about this? Now, if this body is doing uniform pure rolling, then the velocity of this point, net velocity becomes, and this should be equal to ऐसी की तैसी v naught. पूछो क्यों? वो यों क्यों है तो यों है. मैं देखा टीचर से खुद ही आंसर देते रहते, बच्चे सवाल नहीं पूछते. नहीं मैं आपको पढ़ाना चाहता हूं. नहीं प्लीज आंसर सुनो. सर अरे हमें सुनना ही नहीं है यार. मेरा कई बार होता है ना, when students are sitting in the class. दिखाता हूं आपको. मैं एक स्टूडेंट हूं. टीचर आया. गुड मॉर्निंग सर. बेटा गुड मॉर्निंग. हाँ गुड मॉर्निंग. जैसे कह रहा है पढ़ा के दिखा. टीचर तेरा बड़ा मन है पढ़ाने का, तू पढ़ाई ले. मैं कसम खा के आया हूं, पढ़ूंगा नहीं. I am happy in Udan I don't find such situations. But by the way, let me tell you again. Uniform pure rolling तब होती है बच्चों, it happens when the velocity of this body with respect to the surface in contact is 0. Which means when the net velocity of this point and the net velocity of this plank are equal, clear? Then only the body does uniform pure rolling. Now, in this case, the surface beneath this was at rest. The net velocity of this point was v naught minus r omega naught. Lowermost point जो उसके नीचे body रखा था surface, वो उसका velocity 0 है. So we can say that v naught minus r omega naught is 0. But in this case, इसका है 3v naught minus r omega naught. But नीचे वाले का velocity is v naught. So this has to be equal to v naught. लिखो. So I can say that 2v naught is r omega naught. And in this case, v naught is r omega naught by 2. So if you get a question that if a body is doing pure rolling motion, v is equal to r omega all the time, incorrect. V will be equal to r omega only if the surface on which it is doing pure rolling is at rest forever. यही तो difference है. See, questions difficult नहीं आते हैं, tricky आते हैं. Tricky language में trickiness होती है. अब everybody knows v equals r omega. हाँ जी, इसमें तो कोई problem है ही नहीं. Problem तो बहुत सारी है. Clear? That is one thing I wanted to tell you. Please understand that. Situation 1. Okay? So I told you that in uniform pure rolling, there is no acceleration. This is the condition for uniform pure rolling. Now you would ask me, then what is pure rolling? Now let's see. If I remove this term and I only say pure rolling, it can have a situation wherein this center has a constant ACM. About this axis of rotation, there is an angular acceleration alpha. At any time t equals t, the velocity of this body is VCM. At this particular instant, since it has a constant angular acceleration alpha, it would have a certain angular velocity which will keep changing. In such a situation, if the lowermost point with respect to the surface in contact, अब इसकी velocity कितनी होगी? Again VCM. This will be, if VCM equals r omega, that means the net velocity of this point with respect to is 0. It is doing pure rolling, not uniform pure rolling. But now have a look at the accelerations also. What is the acceleration? ये कितना है? ये कितना है? If I wish to calculate the acceleration of this point, like yesterday I told you, if you have to find the velocity, there is, in rotation, there is only one velocity. In circular motion, there is only one velocity. And what is its direction? Tangential or perpendicular to radius. How many velocities do we have in a circular motion? Explain, answer. How many? One. And it is always, sab log boliye, it is always and perpendicular to. Now, my question changes. How many accelerations are there? How many possible accelerations are there in a circular motion? Two. One is the tangential acceleration, the other is the centripetal or the radial acceleration. But to have a circular motion, the first thing first, the observer has to sit here. If the observer sits here, and I want to find the acceleration of this point, you said there will be a radial acceleration. How much? You said there will be a tangential acceleration. How much? Yes or no? Now I move this observer down. If I bring this observer down, what does it do? Pure translation. In pure translation, what am I supposed to add here? The translational acceleration. Kitna? Now, in pure rolling, VCM has to be equal to r omega, 0.1. 0.2, ACM has to be equal to, this has to be equal to, भाई अगर इस lower most point का acceleration 0 नहीं हुआ tangential, तो ये constant कैसे रहेगा? नहीं बात समझ में आई? You're saying that this point is at rest. ये का possible है? When the acceleration also is at rest, is 0. भाई अगर इसका velocity 0 हो गया, and still there is acceleration, the velocity can change. But in pure rolling, the lowermost point velocity should be 0. वो आपने ensure कर लिया, VCM is r omega. But simultaneously, the acceleration also has to be 0, so that this continues to remain at 0. Yes or no? Now, if I ask you, what is the net acceleration of the lowermost point at pure rolling? 0. ये क्या रह गया? So is the net acceleration of the lowermost point 0? नहीं बोलो, ऐसे ये नहीं होता. No, है 0. At pure rolling, the lowermost point velocity, the point, उसका velocity कितना होता है? 0, non-zero? 0. Acceleration 0, non-zero? Non-zero. But tangential acceleration 0, non-zero? लिखो. Are you clear? Should I repeat again? बताऊं दोबारा? मैंने बोला, what did I say? I said that when a body does uniform pure rolling, the word uniform means constant velocity. Uniform is constant. Motion is velocity. So when I'm saying uniform pure rolling motion, it means the velocity is constant. How can velocity be constant? If there is no acceleration. That means in uniform pure rolling, ACM is 0. Alpha is 0. Number one, condition number one. Condition number two, if it is doing pure rolling, then the velocity of the lowermost point has to be 0 with respect to the surface in contact. Clear? The velocity of the lowermost point will be equal to the velocity of the body on which it is kept. That is condition 1. Now let's come to condition 2. When I say pure rolling, now pure rolling does not have a term uniform. That means there will be ACM, there will be alpha, which means there will be a torque, there will be a net applied force. So that means there will be an ACM and there will be an alpha. Ab alpha मैंने constantly, I have taken alpha as constant. So at any instant, there will be omega also. When there is angular acceleration, there will be angular velocity. If there is ACM, then there will be VCM. Ayana. Now, if you see the lowermost point, it has 3 accelerations. ACM on the right, hai nahi hai? R alpha on the left, omega square R along the radius. Now, the tangential, what is the value of tangential acceleration? ACM and R alpha. Opposite hai? If ACM equals R alpha, if there is a condition, what will be the tangential acceleration of the lowermost point? What will be the net acceleration of the lowermost point? Omega square R. So when people say, or when the question is asked, at pure rolling, is the net velocity of the lowermost point 0? Yes, it is. Add one more line with respect to the surface in contact. If they ask you, is the net acceleration 0? Wrong. The tangential acceleration is 0, but the net acceleration is non-zero. ये clarity है पूरी? लिख लीजिए. Are you enjoying it? Now, coming back to that question. Right now, I'm taking a case of uniform pure rolling, and I wanted to find what is the center for this point. It is your pure rolling, so this will also be. The resultant will be along 45 degrees. How much? This is the net velocity. I told you the center of the ICR will lie along a line which is perpendicular to net velocity. Suppose now the center can be here, the center can be here, the center can be here. Suppose I say the center is here. So this becomes the radius of curvature, rho. Now, yesterday I told you rho is, and now I'll explain you why use omega square R and not use V square by R. What is the net velocity here? What is the acceleration here? Now, if I say acceleration is V square by R, it's wrong. Because velocity here is not V naught, instead it is. Are you getting my point? By suppose I write V square by R. तो मैं लिख देता हूं यहां पर V square by R. Right there. ये कट गया, कितना आ गया? But ये तो गलत है. It's wrong. Let's understand why it is wrong. Because the velocity here is not V naught. It is. But yesterday I told you the angular velocity of every point on this disk is same. If I have this as the axis of rotation, the angular velocity of this will remain omega. If I have this as my axis of rotation, it will still remain. So instead of this, just have a look at it. If I were to use, तो मैं क्या लिखूंगा? Yes or no? Right, very good. Now, what is the value of omega square r? Now, can I write omega square here directly? Can I write it like this? Let's find out. What is this? What do you mean by AR? Radial. For this velocity, for this point, where is the radius? Radius कहाँ पर है? ये radius. कहाँ है? Radius ये. मानते नहीं मानते आप? So that means ये तो गलत है. ये भी गलत है. This is the radius. Now, what is the net velocity, net acceleration of this point? It is uniform pure rolling, which means there is alpha is does not exist. So what is the possible acceleration? How many accelerations do you have? A tangential and radial. Tangential is 0. So you only have radial की direction तो radius के long ही होगी ना. And I just now told you what you should use is omega square and not v square by r. Right. This is the radius. Radial acceleration means the acceleration of this point along the radius. That means I need this component of what? Of acceleration. Yes or no? How much is this angle? 45. 45. It's a 45 here, na? So what is the acceleration? By, I'll substitute it here. What is the net velocity? Root 2v. So this will become upon, what is AR? By 2. What is V equal to? V not equal to R omega. So what can I write? R square omega naught root 2 पर चला गया upon yes or no? ये गया खत्म कितना आया? What is this distance? Root 2. Arey, this is R. This is R. How much will this distance be? And what is my distance? That means इतना ये नीचे यहाँ पर भी आएगा. So the center for this point is this at a distance. Absolutely clear? You have a test today for gravitation? तो मुझको वहां पर भी जल्दी से पहुंचना पड़ेगा. Did you read gravitation and come? Okay, good. Farafat, try this question also. Can you find the center for this point also, about which the topmost point is rotating? I mean, find the ICR for the topmost point. Try kariye. Let's see. It's a small test for you. जल्दी जल्दी करो. What is the velocity of the topmost point? 2v naught. ऐसे करो बस. What is the velocity of this point? Fantastic. Where should the ICR lie? Somewhere here. Suppose this is the center. What is this? Fantastic. What is the acceleration along this direction? So what should be rho equal to? 4. What is V naught equal to? So if this distance is 2r, this further distance will also be fantastic. Clarity hui? That's the way to go about. I think I've answered the query of that boy or girl. Oh, sorry, girl. It's Suran. Now, can I move further? Are we clear? कोई डाउट तो नहीं है? चलिए, next. Let's move on to the next question. Great. The question is this. There is an arc of a circle and it subtends an angle alpha होगा ये. This is a linear mass distribution. अभी तक हमने क्या किया था? We took a rod. Now we are taking a curve, right? So this mass is m, the radius is r, and there's a small mass m naught kept here. And I want to find the force of attraction between this arc and the mass. Start. Thank you. Alpha. The angle is alpha. वो बनाया तो मैंने. कौन lambda? Okay. That's mass unit length कितना हो जाएगा? M by r theta. Alpha. Alpha लिया ना मैंने. What is the angle it subtends? So ये जो लैम्डा कह रहा है ना, लैम्डा इज मास पर यूनिट लेंथ, सो दिस विल बी m बाय, तो बाद में सब्स्टिट्यूट कर देंगे. So my dear girls, how do we go about it? First of all, very intelligently, we make a bisector so that it is symmetric on both left and the right hand side. मेरा लग रहा है सिमेट्रिकल? नहीं लग रहा है? कभी हाँ भी बोल दिया करो. हाँ सर, बहुत सिमेट्रिकल है. Come on, motivate me also ना. Very symmetrical ना. Oh my God, that's so nice. अब जैसे आपने इन यस सर बोल रहे तो बोल रही, हाँ यस सर, वेरी गुड सर, कमाल है. लाइक इन द रॉड यू टुक एन एलिमेंट x एंड dx, यहां क्या लोगे? डिफरेंस क्या हुआ? dm तो वहां भी लिया था. यहां पर वी विल टेक द लेंस ऑन एन एंगल. लाइक फॉर एग्जाम्पल, suppose I take this as theta, this becomes, I like it, perfect. So this length will become, what will the value of dm? Total mass kitna? Per unit length kitna? And what is the length of this arc? So what is dm equal to? First thing first, पहले निकाल के बैठ जाते हैं. Wow, how relaxing. Now what do you do? What will be the force between this element and this element? It will be along this direction only. df. And similarly, on the other side. Interesting now? Same theta, d theta. ठीक है ना? सही पूछ रहे हैं. df वा. So what will be df net? हम इसी जन्म में बता दीजिए. हम चाह रहे थे कि रहते रहते समझ जाएं, लिख पाए जी. वेरी गुड गर्ल्स. 2 मचाइए. df का वैल्यू लिख लें. व्हाट इज वैल्यू ऑफ df? जी इतना सुस्त जी. dm लिखिए तो, लिखिए तो. इतनी साफ हैंड राइटिंग, ये खुद ही के पढ़ने के लिए है. थोड़ा हैंड राइटिंग इंप्रूव करिए, नोट्स प्रॉपर बनाइए, because you're going to use these notes after 1.5 years, right? So notes should be visible to you. आगे सॉल्व करना है, प्लीज करिए. You know how to integrate, right? Please explain the value of dm. I like it. कौन एक्सप्लेन करेगा? सब नीचे देखना शुरू कर दिया सबने. आप आओ, कम कम. या आपका नाम क्या है? जूनियर प्रोफेसर शिवानी. प्लीज एक्सप्लेन. He wants, she wants to know how do you find dm?
Yes, dm is the total mass of this arc upon r alpha, which we get from the value of lambda is equals to m upon r alpha, the uh, into r d theta.
ये था पढ़ के बताना। वो पूछ रही थी कि कैसे आया लाइट, बट वेल ट्राइड शिवानी। आप कहाँ के रहने वाले हो? दिल्ली। शिवानी नाम लिखना तेरा मैं आगे। कल्याण। What is the rank you're aiming for? You mean a double digit rank? I mean under 100 in JEE advanced. साइन कर सर, जरा जूम करें। ये मैंने एक वो ले लिया, क्या बोलते हैं इसको, कुछ तो बोलो, प्रूफ। हाँ, वेरी गुड, आई लाइक इट। गुड शिवानी, सो वील रिमेंबर you wrote something here like this. I'm so happy, and your confidence, it's very, very boosting. I wish all the best and God bless, and we will do it together. Great. Good job, Shivani. So dm, actually let me explain. Dm is the mass of that small element. How do you find mass of a small element? If you know the total mass upon the length will be mass per unit length. What will be the total length? If this is r, then this total length will be r into alpha. So m by r alpha will be mass per unit length, right, Shivani? And I wanted to find the length of this element. So if this is d theta and this is r, it will be r d theta. So dm is this. आपने सॉल्व कर लिया? Yes, my dear girls. If you see this, everything is a constant here. You don't have to get bothered. Don't, the length of the equation should not bother you. We finally have to find cos theta, d theta, yes or no? Now, how does theta vary? From minus alpha to alpha or from 0 to alpha? Oh, very good. Solve हो जाएगा? So this will be sin alpha, sin theta, 0 to हाँ भाई, very good girls. I like it. Great. Solve हो जाएगा? Perfect. You're great girls यार. तुम तो रॉक स्टार्स हो सारे के सारे. सब कुछ आता है आप लोगों को. हाँ, रॉक स्टार्स. Okay. Now let's move on to the next concept. एक theorem है which is called the shell theorem. I tell you what the shell theorem is. It says that if I take a shell is a hollow sphere. That means the mass is only on the surfaces. Say the mass is m and the radius is r. If I keep a small mass m naught here, then the net force on m naught is 0. लिखो. Repeating. if we have a shell is a thin sphere, mass is m, and at the center I keep a small mass m naught, then the net force on m naught will be 0. I said not the force on m naught is 0. I said the net force is 0. Very logical. But if I take an element here, I can take an element here also. This attracts 0. I take an element here in here. So all diametrical elements will finally. Now I'll extend this theorem a bit further, not just at the center. If I take this mass anywhere in the shell, even then the net force acting on m naught is 0. Note it down. This we can prove from Gauss law. Gauss theorem होती है जो मैं आपको क्लास 12th में इलेक्ट्रोस्टैटिक्स में कराऊंगा. So we can use this Gauss theorem to find out this status that in a shell, that means inside a shell, the net force is always 0. Anywhere. Please note it down. How do we use this theorem and what is the relevance? See, when I talk about Earth as a solid sphere, there are two important things. A, as I move radially outward, the mass will keep increasing. The mass at the center is 0. But as I move outwards, the mass it occupies keeps increasing. So there is a mass distribution which is radially changing. So radially the mass distribution is not uniform. It is non-uniform. We say it's a uniform distribution. We say that the mass per unit volume is constant. Perfectly fine. But there is another thought also, is that when I radially move outward, the mass will keep changing. Number one. Now, if the mass is changing, even the distance is also changing. And gravitational force is a function of both mass and distance. That means even the gravitational force will change. Likhiye. This is an extension of the shell theorem. Okay? Now, in case of Earth or in case of solid spheres, if I want to find out, say this mass is m and the radius is r. Radius of this, it's a solid sphere. Earth is a solid sphere. And say this distance is x. From the center to the point CP is, say, x. And I wish to calculate the net force on this mass. Say I keep a mass here, m naught, the net force on this mass. Then the theorem states, the shell theorem states that for a point which is outside the sphere, the entire mass of the sphere can be concentrated or taken as to be concentrated at the center. Please note it down. The theorem states that if a point mass m naught lies outside the sphere, the solid sphere, then the entire mass can be assumed to be placed at the center. इसमें कुछ थियरी की भी स्लाइड्स है क्या? नेक्स्ट स्लाइड बनाना. I think I took आगे next आगे left later. Great. Right. I'll explain this. I've got slides which will explain you the theory also. Now, which means if that's a solid sphere and that's the center, then the force acting on m naught will be G and the direction will be along the line joining the center and this point P. This is going to be F. Right, girls? Now, this is called a force. If I divide this force by the mass m naught, this is called gravitational field. So instead of, this is force, but if I want to find field, gravitational field, then that is Gm upon. It is logically correct also. When I'm saying gravitational field, so gravitational field is because of capital M. It's not dependent on what small m is. Force will be dependent on m naught. Because force तो m naught पे लग रही है, लेकिन field तो capital M ही create कर रहा है. So gravitational field should not have a small m, instead should have a capital M. Now, this is what I wanted to tell you. ये चीज clear हो गई? Next slide. This is exactly what I wanted to tell you. Field due to a uniform solid sphere. Now, if I come to an internal point, which means if I want to find the gravitational field at an inside point, I'm talking about case B. I want to find it here. And this distance is x. Okay. Now the Gauss theorem states that the force on this point P will be only due to the mass which is circumscribed in the sphere. Only this mass is going to apply a force on point P. Please note it down. That's a Gauss theorem, and it states that the mass which is inside this circumscribed sphere will exert a force on the small mass. Right, girls? Now, which means if I had a solid sphere and I wanted to find force on this point P, we just now said that for an external point, I can assume the entire mass to be at the. That means if I see the sphere, this point is an external point, and I can assume that the entire mass is placed at the, provided I know the value of the mass. So what will be the value of this mass? Let's find out. What is the mass value of dm? M upon. It's solid, so it will be m by. And what will be the volume of this? So dm is going to be equal to m लिखिए. You see this result coming? And you see the difference in the way you study. Now suppose I write a sphere through a pointer r ray, determine the mass of the sphere, assume it to be constant. Now when I say assume it to be concentrated at the center, you feel there's this type of a formula. अभी ये formula लग रहा है, लेकिन जो explanation अभी मैंने आपको दी है, that what is the reason for it to be assumed at the center, that makes this statement look very, very strong statement. So its strength, if you want to give strength to your statements, you have to be conceptual clarity has to be absolutely clean and clear. अभी बिल्कुल clear है बात? Absolutely. So next slide, please. Now, can you find the value of force here? क्या लिखूं? G dm. If I want to find gravitational field, तो E ले लूं, G m upon x square. So it's G m x cube upon r cube into x square. So this is G m upon r cube into do you agree? है ना? Now, if I were to plot the gravitational field intensity versus distance from the center, if I wanted to plot, so initially when x is less than r, I mean when you are inside, that's a variation. This is a constant. It's a linear function, a straight line. When you reach here, P point is outside, then I told you it will be G m upon. This distance becomes x. It's a hyperbolic function, so there is a fall. And this value will be equal to, लिख लो, of course. Yes, there will be no gravitational force for a point which is located at the center. At the center, the gravitational force will be zero, obviously. Next point. Now this explains the shell theorem. See, I've written uniform spherical shell. This was a body which had mass inside. In a shell, the mass is only on the periphery, on the circumference, outside. So what should be the force at a point which is inside? What's your name? Mansi. What will be the force inside? Shell, hollow, shell theorem. 5 minutes back I explained. What is the net force? If I have a shell and I hollow sphere, if I place a point P inside, what will be the net force there? Yes, that's what I'm asking. Mansi confused हो गई. देखो रे लिखा हुआ है. R less than R, E is. ये थोड़ा bright नहीं हो गया ज़्यादा? Very bright ना? तो decrease करो ना. I like it. ठीक है? And Mansi, for an external point, I'll assume the entire mass of the shell to be concentrated at the. Fantastic. Perfect. Third slide. Next slide. Right. Now, certain cases. In case of Earth, you would assume a solid sphere. In a normal theoretical question, we can assume a spherical shell. But there can be a theoretical situation where the shape of the mass, जैसे हमने shape of the mass कौन से लिए? We took a rod, then we took an arc of a circle, then we took a hollow sphere, then we took a solid sphere. It would be a ring also. What happens in case of a ring? So, Mansi, if there is a ring which is kept like this, ring, and I want to find a force on the bisector passing through the center. That means at a point which is perpendicular to this plane, on the axis which is passing through the center. Logical है, center से लेने का मतलब I want it symmetrical. So I want a point which is symmetrical. What is the value of gravitational field intensity due to a uniform circular ring on a point on the axis? लिखो. ना भाई? क्या करेंगे? एक एलिमेंट यहां ले लेंगे. We'll take one element here. This will be df. This again will be, and this will be df net. And if I replace this mass with a point mass, I can call it dE net. Instead of force, I can use gravitational field. If I integrate this, we get this relation E equals Gm. I take x generally. Instead of r, take an x. X looks more a variable. Upon whole to the power 3/2. इस result को आप याद कर लो. You can derive it, but then it takes a lot of time. So you can simply, and if you have H.C. Verma or any of the good textbooks, you will have this derivation there. But have you understood how this result would have come? Now you understand that? Element कैसे लेते हैं? थोड़ा बताओ इसमें element कैसे लेंगे? थोड़ा बता ही देता हूँ. Okay, Shivani. ये रिंग अभी ऐसे रखी है, प्लेन के परपेंडिकुलर. मैं इसको रोटेट करके ऐसे ले आता हूं. So this point comes here. Now, मैं क्या कर रहा हूं? What I'm doing is theta, d theta, r d theta, dm m upon 2 pi r into. अभी क्लियर हो रही बात? So I have a dm, and then I will finally integrate theta from 0 to 2 pi. Are you at a moment? If I solve this, I get this answer. अब मैं आपको एक छोटा सा शॉर्टकट बताता हूं, trick. Generally in rings, they generally ask you to plot the curve. Now suppose I have this expression. You're mathematics students. Can you plot E versus X? So it's not a physics question anymore. It's a mathematical situation. Can you plot the gravitational field intensity for a ring versus X? Can you try doing that? Class 11:30. Now I'll give you a hint. Let's see. Hint in the way that how to make this graph in a much smarter way. If I keep x as 0, E will definitely be 0. So I get a point here. This is E. This is X. Right? If I take x tending to infinity, what will the value of E? You want to find it out? Okay, let me do one thing. It is gmx. Let me take an x common. So if I take an x square common, I get an x cube outside, am I right? Yeah. So this is r square by whole to the power. This becomes square and this goes off. So I have a gm x square 1 plus r square by x square. Now if I take x tending to infinity, the whole thing will tend to 0 again. देख लो, ये इंफिनिटी हो गया, ये खानदान 0 हो गया, और ये खानदान या इंफिनिटी है तो पूरा खानदान tending to 0. That means it's a very smart curve. At x equals 0 it is 0, and at x equals infinity it is again 0. That means from 0 it will rise and then fall and then tend to 0. You agree with this? Right. अब problem क्या आएगी? When does the fall start taking place? growth starts from 0, ends at infinity, but then where is the point, what would be the point where this value will tend to the maxima, jahan se slope down jana shuru karega. Interesting. Now, if I want to find out where the maximum value of E lies, I have to do one thing. And put equal to. That's the only way. If I wish to find out the value of the maximum value, where the value of E will be maximum. So maxima and minima only happens when you have a slope equal to, then only the curve changes its shape. So I have to find dE by dx. That's step one. But that's a long step, boring step. Let's look at more interesting. Now, if for this type of question, I figured out a good method is just check out with the denominator. देख सकते हो denominator को? X square को लिखो आप for maxima. Whatever it is here, write it here and divide by 2. So what is x equal to? ये इसका maximum value आएगा. For example, you say, sir, ये तो बड़ा convenient था आपके लिए. ये x square है, r square है, आपने मचा दिया. Suppose ऐसे होता, denominator में. तो भी मैं वही करता. Goodness, smart way. Yeah, I like smart things. Long things are boring. Like I feel inorganic chemistry is so boring. So if I were to teach inorganic chemistry, I should make it interesting. I'll tell you a way to make it interesting. Anything which is not interesting, you will not be able to do it. We are all humans, right? Machines थोड़ी हैं. We are not programmed. If anything which is not interesting, bothering, it doesn't happen. So if you want that thing to happen, you have to make it interesting. You want to get selected in IIT, then studying to IIT should be, and not. But at the end of the day, you need to fill the right bubbles and fill the right OMR sheet. Done. तो उसका ग्राफ कैसे बनेगा? ये रिंग था, यहां पर रिंग है ना ऐसे. I was taking a point on the right hand side. अगर point मैं left hand side पे लेता तो ऐसे बनता ना. And this value again would have been equal to अब आप कहोगे कब आपने नीचे क्यों बनाया, पूछो. Very good. Also, on the right hand side it is positive, on the left hand side it will be negative. Yes. Good. Smart girl. Smart girl. Next slide. Disk. Instead of a ring, if you have a disk. Disk का मतलब क्या होता है? It's like a plate, a circular plate. So if I have a disk, what happens? Have you understood the graph? कैसे बनाया? तो मैं चाहता नहीं था कि आप सिंपली इसको रट्टा ही मारें. ग्राफ को या बना के देखें. Both are boring. So maybe a smarter way to understand these graphs is this. Now you see the disk. Okay. Now the gravitational field at a distance x from the center, the radius is r, mass is m. Now E is 2g m x upon r square 1 by x minus 1 by x square plus r square whole to the power half. Now you have to remember this result. There's no other way to do it. What will be the value of gravitational field intensity at x equals 0? Batana. What will be the gravitational field intensity at the center of the disk? 0. Likho. E is 0. Good. Right? Now with the same concept, with the what things we've learned till now, if I wish to calculate, now, how do you define g? The acceleration due to gravity g, how do you define that? It's acceleration due to gravity. Like for example, if I say that this is Earth is solid, sphere, and I've kept a mass here, m, the center is capital M, the radius is r, then what is the force which is acting here? Perfect. This is the force. If I want to find out what is the acceleration on this mass, I call it g. So when we deal with Earth, we talk about, see, there are two types of masses. There is an inertial mass, there is a gravitational mass. So gravitational mass is specific related to Earth. Astronomy wala part alag kar diya. Baat ek hi hai. So that means on the surface of Earth, the value of acceleration due to gravity is gm upon. This is on the surface. Now instead, if I want to go down or go up, let's start with up first. Suppose I reach here, and this distance is x. Can you tell me the value of g here? G dash if I were to call it. Nikalna. I'll first find the force. Kitna? I'll call it F dash. Yeah. And G dash, yeah. So if I find G dash by G, you get. So this is going to be so that's a relation. Okay. Now if I take a special case that x is small as compared to r, अब इसको थोड़ा differently कर सकते हैं treat. So G dash will be G. If I take an r square common, I mean G dash could be like G 1 plus x by r. And if x is small, I can probably use a binomial theorem. Yeah. And might be G dash is G into 1 minus लिख लो. So maybe I can say that when you go up, the value of gravity falls. So if I want to find the percentage of fall, so it'll be like g minus g dash by g. How much is that? 2x by r. Now I'll tell you what mistake students do. हर चीज बेचारे बच्चे गलत करते हैं. How rude was that? Let's put it like this. Let's see what mistakes we all do. Suppose ये सब कुछ आपने सेटिंग करके गए, सब मालूम, एग्जाम में क्वेश्चन आया that x is equal to r and find the percentage change in the value of g. आपने टकाटक मारा 2r by r which is 200%. into 100 भी लोगे ना. सब लाइफ ठीक थी, चल थी, जिंदगी सही चल रही थी और सडनली एक्सीडेंट हो गया. कैसे हुआ एक्सीडेंट? क्योंकि जब आपने इसको डिराइव किया था तो आपने बहुत घोटे मारे थे कि x will be very very small as compared to, और हम लूट गए. क्योंकि एग्जाम करते वक्त, एक सवाल आते वक्त हम ये भूल गई ऐसा होनी थी, क्योंकि हमको तो ये फॉर्मूला याद करके गई थी, हम रट्टे मार मार के गई थी. 2x by r, 2x by r, finished, over and out. तो ये क्वेश्चन ऐसे नहीं होएगी. हाउ? वो जितेंद्र शुक्ला इतना बड़ा, ये कौन है? स्टूडेंट है, टीचर है ये? अगर ये स्टूडेंट तो मैं ठीक है, टीचर है तो इसको बोलो, मैं उसको मैसेज करो कि ये इतने सारे क्वेश्चन मार्क नेक्स्ट टाइम नहीं डाले. दैट्स रूड. दैट इज कॉल्ड अ रूड बिहेवियर, है ना? So he should understand this. He says, वो क्या क्वेश्चन पूछा? Oh, that's my problem. I mean, if I take x as r less than r, I want it this way. है कि नहीं? मैंने क्या बोला? अगर x r से छोटा नहीं है तो फिर, और अगर है तो, if I take x as very very small as compared to r, like for example, what is the radius of the earth? 6400 kilometers. और मैंने कहा मैं 10 मीटर ऊपर जाना चाहती है, ये 100 मीटर ऊपर जाना चाहती है, तो x बहुत छोटा होती है. सो अगर x बहुत छोटा होती है तो हम करती है, और if x is not छोटी होती है, like in this case, तो फिर हम ये नहीं करती है और हम यहां पर इधर जाते हैं. So what do you do, girls? So g dash is g r square upon r plus r का कितना हो गया? Like it's g r square upon 4r square, right? So this is like g by 4. And not, ये कितना हो गया था हमारा? इस हिसाब से चलते अगर हम, g dash would have been equal to g into 1 minus 2r by r. कितना हो जाता है ये? Yeah, that would have been wrong. Clear? So you in the question you have to understand when you have to use this. So that becomes your general formula. That is your general formula, right? And this is a special case. Now let's talk about a situation. Have you understood this? So if x is less than r, then that's how we go about it. कोई और भी question है? Great, I like it. आगे चले? Ask Mr. Shukla, has he understood it? If he is Jitendra Shukla, ask him, has he understood this, or should we move forward? Have you girls understood this? Very good. Now let's take a situation where this point is inside the earth. X अंदर ले जाइए. This is the surface of earth. and there I am. And I want to find the value of G dash. So we just now understood क्या बताया था मैंने? Gauss theorem. Only this mass is going to participate. याद है ना? करो करो करो. Solve it. पीछे नहीं देखना बालिके. जीवन में आगे ही बढ़ा जाता है. No U-turn. आपको समझ में आ रहा है? आप एंजॉय कर रहे हैं? Good. बता. R minus X हो जाएगा. If this is R, this is X, so it will be R minus X. Done? Good, 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 good. G. What will be the net force F dash? G. M dash ले लो उसको. ठीक है ना? This is E dash. Yeah, or G dash. G dash लिख देता हूँ. And what is M dash? M by straight away लिख दूँ. यही है ना? But in this case it will not be X. So G dash, my dear friends, is upon R cube. Is it? And what was G? So G dash yes. Right. So what is the percentage change in G? Again, if X is, or if it is, and if it is not, ठीक है, एक देखते हैं, लिखो इफेक्ट ऑफ रोटेशन ऑफ अर्थ ऑन द वैल्यू ऑफ जी. Understand what does it mean? ये अर्थ है. Now the logic says that if I have kept a body here, what will be the direction of G, by the way? Vertically downwards or towards the center? Towards the? Very good. But now imagine if Earth, obviously, is rotating with an angular velocity omega. See, G is net force by mass. So if the Earth is stationary, then the net force is G. By mass is G. But if it starts rotating with an angular velocity omega, then if you see this path, if this particle, explain special case. कौन से वाला? Okay. Two cases we discussed. If we take a particle above a distance x, radius is r, the value at the surface is g, at this point is g dash. मुझे फटाफट जरा मेरी हेल्प करो, g dash का वैल्यू कितना निकाला था हमने in terms of g? No. Not the special case, the general case. बोलो. This is the general case. This is the general case. That means if I take a body from the surface of the earth above the surface of the earth, that's a value. But in a special case, if x is very, very small as compared to r, what will happen? G dash can be written as, I'll take an r square common. The r square cancels. So this becomes g into, since x is very, very small, I can and using binomial theorem, this can be written as आप ही करते रहो ना, परसेंटेज ऑफ जी. बताएं परसेंटेज माय डियर स्टूडेंट्स कैसे किया था हमने? We finally get g dash equals g into 1 minus. Now percentage change is g, which will be क्या कह रहे हो? Oh, depth case. शिवानी तू ही कर दे सॉल्व. आजा. Come. I'll rest till then. Come.
अगर ये अर्थ की बॉडी है और ऑब्जेक्ट इनसाइड द सरफेस है, डिस्टेंस x पे तो फिर
mass inside कितना होगा? The force on the body at this point will be due to the mass inside. लिखो m dash कितना होगा? g नहीं m by r cube into r minus x whole cube. Shivani, your voice is not coming.
yes sir.
So let me become Shivani. Now I am Shivani. Right. So शिवानी की वॉइस श्रिल थी, मेरा बहुत खतरनाक। सारी कहानी करने के बाद बोलते हैं ये नहीं चाहिए था। कितना कन्वीनियंट है ना। ना 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 वो मास्टर वो बता, तू चुप हो जा। यू हैव टू बी ऑन माई साइड। We move a distance x below. I told you earlier that if I want to find out the value of force on a mass in a solid sphere inside, then according to Gaussian theorem, I need this mass. Yes or no? What is this mass? M dash. Yes? What will be the force? G m dash upon, what is the distance this has? This is whole. So substitute the value here. And in this case, this R will be, है ना? Yes or no? That's all. So this becomes Gm this is G dash and G was so percentage change कितना हो गया? जी सोचा इसके बारे में कुछ? What happens if the earth starts rotate? I mean, what happens here? Earth तो rotate करती ही है. Now, with respect to earth, this point will move in a circular motion like this. And this will be the centrifugal force. This radius, if I take this as lambda ले लूं उसको या इक्वेटर से लूं. If I take this as lambda, theta, whatever, theta ले लो, lambda ले लो, तो ये कितना हो गया? R cos lambda. This will be m r cos m r. So the net force will be resultant of this, the component of this force here and this. So what will be G dash equal to? G minus, if this is lambda, what will be this value? This also is lambda, right? So this will be G. M हटा दूं फिर? Acceleration ले रहा हूं ना? पागल से तो नहीं हो गया? सब समझ आ रहा है ना? वैसे हाँ कर रहे हो अब? क्या लिखूं? R अल्फा क्यों लिख दिया? लैम्डा into omega square. So the net value is this. लिखो. that's the effect of rotation. Clear ho gaya na? So it's G dash is G minus R omega square cos square lambda. Like for example, at equator, what will the value of lambda? 0. So cos square lambda becomes, so it is G minus R omega square. At the poles, lambda will be 0. So cos lambda will be 1. उल्टा तो नहीं बोल दिया हमने? हाँ, मतलब lambda जब equator पे 0 लेंगे तो cos lambda will be 0. 0, cos 0 is 1. और उधर जाएगा cos 90 and cos 90 will become 0. Good, good, good. Note it down, please. लिख लो उसको. Cos का भी square कैसे हुआ? This value is R omega square cos lambda. If I want to find the value G net, so I need this component of this acceleration. So this will be R omega square cos square lambda. ये तो cos lambda था, इसका if I take a component of this here, so it will become R omega square cos square lambda. ठीक है? ऐसे ही जैसे ग्रेविटेशनल फोर्स है, ग्रेविटेशनल फील्ड है, ऐसे ही ग्रेविटेशनल पोटेंशियल एनर्जी भी होती है. लिखो. Or if I were to say, okay. Now before that, let me explain you why should we have a gravitational potential? Let's first understand that. What I'm trying to say is, when is potential defined? There are two types of forces. There is a conservative force and there is a non-conservative force. What is the difference? मैंने बताया भी था आपको. What is the difference between a conservative and non-conservative force? Non-conservative are path dependent and conservative are path independent. Great. Now, which means they do not depend on the path you take. The work done is independent of which path you take. That means they depend on the initial and the final state. So that is why we say that they are state functions. So anything which comes out from a conservative force automatically becomes a state. मुझे जरूरत ही नहीं है मुझे कहां से कहां जा मतलब कैसे जा रहा हूं. I need the initial position and the gravitational potential. That is why it's a state function. That is why we say potential energy at this level. आप जब ये बोलते हो, a ball is taken from this position to this position to hide this. You never mention what path, because gravitational potential or gravitational potential energy is a conservative force. Gravitational force is a conservative force. So basically, potential can only be defined if the forces are conservative. Gravitational forces are conservative force, and that is the reason I can use this formula also. I can only use this formula if the force is conservative. Note कर लीजिए इसको. If the force is conservative, which in case of gravitation it is, therefore I can define F as minus du by dr. The basis, and this equation forms the basis of finding out potential energy, because then I can say that du is minus F dot. Are you getting my point? And gravitational potential is gravitational potential energy per unit mass. That's how you define gravitational potential, is gravitational potential energy per unit mass. And by the way, F by m is E. Yes? So the gravitational potential change, that is dV, is basically minus E dot dr. Are you getting my point? So that is how you find नहीं clear नहीं हुआ? Gap आ गया बीच में? कौन सा? Hello. How do you define work done? Or how do you define gravity? How you define potential energy? Du is the negative of work done by conservative forces. And a first definition in work power energy, the first definition of gravity of potential energy. Forget about gravitational potential energy. The potential energy is its negative of work done by conservative forces. What is this? What is F? लिखो. अब मैं आपको ना फटाफट कुछ वैल्यूज लिखा देता हूं. I don't think we have good enough time to derive them. लिखना फटाफट. Like for example, if I want to find gravitational potential at a distance x greater than r, समझ में आया बात? Which means I am at an outside point. उसमें क्या define किया था हमने? The entire mass is kept at the center. So gravitational potential V will be okay, girls. At the surface, ठीक है? Inside. This result you have to remember. Okay. Okay. And if this is x less than r, मतलब मैं अंदर आ गया. Now at x equals 0, at the center, put x equals 0. कितना आ रहा है अभी? Yes. ये वैल्यूज आपको याद करनी है. I don't think they're very difficult. ये थोड़ा सा वैल्यू. This is okay. But this is fine. This is the only value which you have to remember. Which actually means the gravitational force at the center is 0, but the gravitational potential is not 0. They're not 0. Potential will exist. The net force could be 0. Yeah. Question दिखाना है. Slides on. Like for example, let's take question number 14. Try करना. Yes, it is gravitational potential. These are the values of gravitational potential. G. करिए. How will you find where the net force is 0? I think we can solve it, isn't it? You have a mass here, 9m. You have a mass here, 16m. And they're separated by a distance d. And he says at what distance from 9m is the gravitational field 0? Let's take a distance x. How much is this distance? Gravitational forces are attractive forces. ये भी इसको attract करेगा. So there is a possibility that the net force becomes 0. कितना होगा? G 9m by is G 16m by d minus x. Take an under root. Done. Simple. Next question ले लेते हैं. 15th. 16th ले लेते हैं. Let's take 16th. How much time are we left with? तो फिर चलो let me define then. लिखो. Let me define Kepler's laws for you. इसको स्लाइड को भी रहने देते हैं. लिखिए. The first law, Kepler's first law, is called the law of orbits. It's called the law of orbits. This law states, the law states that all planets move in an elliptical orbit with sun at one of its foci. With sun at one of its foci. So this is the focus. And here the sun is present. And the planet is moving around the sun. Now there are 2-3 informations I want to give you. Is this length is called A? Are you aware of this? And this length is called? We define something called eccentricity. E. क्या होती है eccentricity की value? C by A. Oh, hello. हाँ, इसको मैं ले लेता हूँ center, इसको ले लेता हूँ A. Now can I say that AF by AC is E? This by this is E. पता है ना आपने को? मतलब AF is actually E times A, which means the distance of the focus or of the sun from the center is no. ये तो A हुआ ना? Am I right? This length is AE, I believe. So what is AF equal to? लिखना. And if I take this as B, then what is BF equal to? ठीक है ना? ठीक है? Next thing. eccentricity for a circle is 0. Obviously check करो कैसे, इधर देखो, अब ये AF और BF है, this length is AE. So if it is a circle, then AC will be equal to, तो तभी होगा जब E will be 0. एक चीज और नोट करो, for Earth the value of eccentricity is 0.0167. This is the approximate value for the eccentricity for Earth. 0.0167. Then the second law, फटाफट लिखो, time कम है, is the law of areas. The law of areas. लिखो. Write the definition first. Yes, the aerial velocity of Earth around Sun is a constant. If you want to write the correct, absolute correct information, तो लिख लो. A line that connects a planet to sun, yes, sweeps out equal areas in the plane of planet's orbit in equal interval of time. In equal interval of time, it says that dA by dt is a constant, which means if the planet covers this much of area and if this radius is less, then it'll cover more area here. You agree? Now if I wish to calculate this area, suppose मैं ये planet का area निकालना चाहता हूं, it starts from here, reaches here. So this angle is d theta and this is approximately r. So what will be the area equal to? ये length कितनी हो जाएगी? So area will be half into r upon time. This is going to be dA by dt. फटाफट लिखो. Now this can be written as half r square d theta by dt. This is half r square omega. Right? Now, what is angular momentum? mr omega square? Yeah, mr square omega. ये होगा ना? I into omega. I is mr square. तो अब अगर मैं इसको m से मल्टीप्लाई कर दूं और इधर भी m से मल्टीप्लाई कर दूं, ये कितना हो गया? mr square into, so this becomes L, and you bring it here, so L by 2m is, so I can say that angular momentum is a, मैंने कल बताया भी था, all the forces are central forces, radial forces. So, and then the third law, फटाफट लिख लो. What is the Kepler's third law? It's law of periods, that t square is directly proportional to r cube. T square directly proportional to r cube. And finally, there is a term which will be used, which is called escape velocity. What exactly do you mean by escape velocity? If a body is, say, placed on the center of, on the surface of the earth, and it is at rest, what will be the potential energy of this body? R. This radius is R. Now he says, what is the velocity I should give it to this particle so that it escapes the gravitational field? So that means infinity. वहां पर पोटेंशियल एनर्जी कितनी होगी? जीरो. तो अगर मैं इसको इतनी ही पॉजिटिव फॉर्म में एनर्जी दे दूं तो उसकी टोटल एनर्जी कितनी हो जाएगी? And total energy zero means it reaches. So what do? You provide this through kinetic energy. So what is V equal to? This is called escape velocity. Okay? Chalo. Thank you very much for your concentration. God bless.
Start. Okay, good afternoon, girls. So last time we were almost finishing permutation combination, right? So we'll just start whatever we did last week, and then whatever the last part is left, we'll finish that up, and then we'll see some questions. Okay. So we'll just see the recap from the pages only. So we understood what do we mean by permutation, and we also understood what we mean by combination. Permutation was talking about arranging. So order was important, but on combination, the order was not important. So it was basically we understood that it's basically going to be the thing of how to count, right? Can you go to the next slide? So then we understood how to add. There was basically two rules when counting comes to the play. There are basically two rules. That is the rule of sum and rule of product. So rule of sum says that when we hear something like or word or cases, we add up. And when we see and or stages, we multiply. As we took the examples of five full shirts and three half shirts, so total 8 shirts. And when I took the examples of 8 shirts and 5 pants, then it becomes 40 dresses, right? And 8 shirts, 5 pants, and 10 ties makes it 400, right? So we are almost saw that, okay, what does factorial means? We also understood what factorial means. We actually derived the expression, right? A becomes 2 factorial. When we have to arrange three things, it becomes 3 factorial. When we have to arrange 4 distinct things, it became 4 factorial. This is the way we actually understood what were factorials. Then also we also tried to find, okay, when I say n factorial, it means that product of first n natural numbers, right? That was the mathematical interpretation of n factorial. And then we discussed what do we mean by 0 factorial. And 0 factorial turned out to be a 1 because of the multiplicative identity, right? Because when we are not multiplying any natural number, what we are multiplying? We are multiplying 1. When we are not adding any natural number, what we are adding? We are adding 0. That was additive identity, right? Can you go to the next slide? So this is how, next slide. Okay, next slide. Okay, next slide. So this was the cases where we understood when to add and when to multiply. So it was basically 2 roads and then 3 roads connecting B to C. So total there was 6 roads. And if you take a flight also, then the total roadways becomes 7. Can you go to the next slide? So we noticed, okay, and is replaced by multiplication and or is replaced by plus. So in cases we add, when we use either or, we also add. In stages we multiply, and when we use and then we multiply. यहाँ पे misprint है. Next slide. Okay, we also understood what is NCR. What was the definition of NCR? When we have to choose R fellows from N fellows. That was NCR, right? And how we also turned out that mathematically it's nothing but n factorial upon r factorial, n minus r factorial, and we actually derived it, right? So you know the derivations. Okay, can we go to next slide? So order was important, but because order was not important, so we had to manage it by dividing it, right? Can you go to next slide? Okay, next slide. Okay, so this was the result, and then we also observed that NCR is equal to NCN minus R. Means if I am selecting 3 students out of 10 students, that is 10C3, it means I am leaving 7 students. So 10C3 is equivalent to 10C7, right? Can you do the next slide? Then we also remember this NCR into R is N into N minus 1 CR minus 1. How to remember this? Selection of a cricket team and a captain. So 50C11 into 11 is nothing but 50 into 49C10. So that makes it NCR into R is N into N minus 1 CR minus 1, right? Easy to remember? Can you go to the next slide? Okay, that was to key, how to keep it in mind. Selection of a cricket team and a captain. Next slide. Back, down, back and down, back and down. So here was the next thing, NCR plus 1 is equal to N plus 1 CR plus 1. Jack is in team, Jack is not in team. So selection of a cricket team makes it 50C11, and that makes it 49C11 plus 49C10, right? If Jack is in team, the selection is 49C10. If Jack is not in the team, 49C11. So 49C10 plus 49C11 gives me 50C11, right? Next slide. So it was very easy. When we went through mathematically, it was a little messy, but keeping in mind, you can do the Jack and team, Jack not and team. Can we go to the next slide? Okay, next slide. Okay, so this was the summary. NCR is NCN minus R, and NCR into R is N into N minus 1 CR minus 1, and NCR plus 1 is N plus 1 CR plus 1. And we can remember Jack and team, Jack not in team, selection of a cricket team and a captain. Whenever we have to prove or we forget, we can remember these things, right? So basically then we actually went to the counting. By understanding the laws and understanding NCR, we saw that we basically started with 3 techniques. The first technique talked about selection technique. The second technique talked about shuffling technique. And the third technique talked about, okay. So first technique was selection technique. We had 3 bags. One bag was of distinct objects. The second bag was of identical objects, and third was of mixed object. Distinct was fine, NCR. For selection, it was NCR. And for selecting from the identical object, it was 1. And for the mixed, you have to break the thing into cases and then add it, right? For shuffling, the same story. We created again the 3 bags. Distinct was n factorial. Distinct was n factorial. And when you have like 1, and when you have to do the mixed bag, you are first going to consider everything as distinct. Then that becomes, let's say you have P likes, Q likes, and R likes. So I can say P plus Q plus R factorial upon P factorial, Q factorial, R factorial, right? After that, we went to, can we go to the next slide? Next slide. Then we have already finished shuffling technique, right? Then we came to the third technique, that was box and letter technique, right? So we first saw that, okay, if I have to put my letters into envelopes, that is a 1-1 relation. One letter go to one envelope. But when we see letter in boxes, it's not 1-1 relation, rather it's 1 many relations, right? I can put one letter in many boxes, but I cannot put one letter in 2 boxes. I can, which one is shareable here? The boxes can be shared, but the letters cannot be shared. So we understood, okay, the power of choice is with unshareable things. So the final answer turned out to be shareable to the power unshareable, right? Can you come down? So this was the story. We discussed this, right? Can we go to the next slide? Next slide. So that was the exercise. We finished these questions. You all, I think you all handled this question. Ghar pe bhi kiya hoga? Can we go to the next slide? Okay, then we talked about circular permutation. In circular permutation, what was the challenge? The challenge was symmetry. It was symmetrical. So for that, we must break the symmetry. If we break the symmetry, everything turns out to be linear then, right? So when we have a distinct objects, what we had to do? Break the symmetry by choosing anyone. We don't have to actually choose. Kisi ko bhi rakh do. That will be fine. The rest of the fellow will be n minus 1 factorial, right? Now when we have to arrange the similar thing, that will be 1. And when we have to see the mixed things, we have to see which of them can actually break the symmetry. Means it has to be single out. So I see, okay, P can break the symmetry. So I could put P there, and then I can fill rest of the fellow in the factorial wise upon the linear way, the way we do it, right? Can you go to the next slide? So it was the way we also discussed this question from IIT JEE that 13 guests were invited to a dinner party in a hall which has 2 round tables, such that in 7 we are recapping it. We are just recapping it. So 13 guests were invited to a dinner party in a hall which has 2 round tables, right? Such that in one 7 guests will be sitting and remaining 6 on the other. Find the number of ways the sitting arrangements can be done. So first, I go into the room, I see 2 tables, I can choose the table, right? Because they are not, I see one left table, I see right, they are 2 distinct tables for me, right? So I chose one table, 2C1, and then I selected 7 fellows, 13C7, I put them there and arrange them in 6 factorial. Rest 6 has been left out, which will be forced to go to the second table, and then I can break the symmetry by putting 1 and then 5 factorial. So answer is going to be 2C1 into 13C7 into 6 factorial into 5 factorial. Good. Can you go to the next slide? Now, we also discussed this variation ki when number of objects to be selected is not specified. So what to do? When we see distinct objects and we don't know whether I have to take all the 5 chocolates or not. So I see 5 distinct chocolates, right? So either I will choose 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5, that finally turned out to be 2 to the power 5. That was law of sums, or we could also go through the law of product by going to each chocolate and asking them whether I am going to eat you or not. So that is going to 2 into 2 into 2 5 times, that's going to be 2 to the power 5, right? When they are identical, 5 identical chocolates, so I have 6 options basically. Either I'm going to choose no chocolate, 1 chocolate, 2 chocolate, 3 chocolate, 4 chocolate, 5 chocolate. So I have 6 options. And when I have a mixed case, I'll break things into cases. I'll put all the likes and distincts as I'll treat it them as a as a group, and then I'll put them as a stages, and then I'll apply the law of multiplication. Like you see, triple A, B, C, D. So I can say I have 4 choices here, 2, 2, 2. So 4 into 2 cube. Clear? Can you come down? So next slide. So this was the remark for n distinct object. If number of object to be selected is not specified, then the total number of selection is going to be to the power n. And for n identical objects, if number of objects to be selected is not specified, then total number of ways of selection is n plus 1. Okay, can you go to the next slide? Okay, this was the sandwich question which we did, and then we had a full of baskets banana, right? Fruits. Can we come down? We all discussed all the thing, and it actually cleared all our concepts, right? Do we have to discuss this question again? No? Okay, next slide. Now, number of ways to distribute 10 distinct chocolates in 3 distinct boxes. I understand that I see 10 distinct chocolates and 3 distinct boxes. So I see this is shareable, this is not shareable. So every chocolate has the power to select the box. So they becomes 3 to the power 10. This was fine, but chocolates are identicals and you have to send them to 3 different fellow. You brought 10 chocolates, 10 are identical. So you want to send them to 3 of your friends. So then you need 10 chocolates all arranged, all like objects, all arranged. Then you need 2 partition to divide it. So basically 10 identical chocolates and 2 identical flags. So basically 12 things arranged in a linear way. So you are going to permutate them by 12 factorial. Now you see 10 identical chocolates, so you will divide them by 10 factorial, and then so finally it will turn out to be 12C2, that is 10 plus 3 minus 1 C 3 minus 1. And then also we found out that this is nothing but the whole number solution of an equation called XA plus XB plus XC is 10, right? Can you come down? This is what we talked about, right? You remember things, right? You have the PDF of this book, right? They must have emailed you. Okay, I've asked, they must have emailed you, or they must be emailing you. Okay. So this is the way we discussed, right? Okay. Can we come down? So it was the generalizing result. Okay, x1 plus x2 plus xr, and then it turned out to be n plus r minus 1 cr minus 1, right? Can you go to the next slide? This was all the questions we discussed. Do we have to see these questions, or you can handle them? This was challenging. G and H. We use the concept of Venn diagram, right? Can you go to the next slide? Okay, there was the Pascal's triangle, right? And we actually enjoyed Pascal triangle. And in Pascal triangle, you saw. Did you observe this when you went home? Did you do all this stuff? No. So you see these things, right? Summing up to 2 to the power 0 to the power 1. Then you see things are adding it up, right? And so on. Can we go to the next slide? I guess you didn't notice that all the patterns of Pascal triangle can be expressed in terms of NCR. You see it? And then I see the sum also if number of objects to be not specified, right? When I have to choose 5 chocolates, this is the story, and I'm getting the sum as 2 to the power 5. Can you come down? Now I call the pattern, the next pattern which I actually started the whole journey of Pascal triangle is because of hockey stick, because we will be studying Pascal triangle again in binomial theorem. So you see this is a hockey stick. It occurs when we add the diagonals of the triangle, for instance. So you understand what we are talking about, right? Next slide. So this was the hockey stick I was talking about. Either you go from left to right, this is going to be the sum anywhere. And if you go from right to left, right? This was the hockey stick pattern which I talked about. Can you come down? A long stick that jets out in a new direction to give the next entry to the triangle. This rule works whether we are adding diagonally going to the left or the right, right? Okay, so we understood, okay, when we are starting some series like 5c0 plus 6c1, so something is starting with 0, and both suffix and prefixes both are increasing by unity. So the final sum, the prefix will add on 1, but the things will, because it's jutting out, right? It's going this way. The curve is going this way on the left side. So subscript will remain same, and this will add on because we are going to the lower row. Same thing happened when, say, we are going from right to left, 5c5, 6c. So it means the suffixes are constant, they are not increasing, but prefixes again increasing by unity because we are going down, so it needs to be increased. So the sum is, and then it's jutting on the right. That is why suffix is also changing. It's jutting to the right. That is why suffix is also becoming 5 to 6. है ना? अगर देखो हॉकी स्टिक ऐसे आ रहा था ऐसे हो रहा है ना, ये हॉकी स्टिक ऐसे आ रहा था ऐसे हो रहा है, तो ये तो सेम रह जा रहा है, लेकिन ये एक बढ़ जा रहा है. Can you go to the next slide? So here it is goes. This is the pattern. They can either show you starting with 0, or they will either show that things are constant, right? If they don't show the 0 thing or the constant thing, you can actually add and subtract, right? Can you come down? So these were the 3 questions. These were the 3 questions we discussed, right? When we opened the sigma thing, it turned out to be a hockey stick. And a hockey stick edge wala part. The final answer would have been the curve part. Can you go to the next? And the third question, the C part, was a broken hockey. So we just add on shorter hockey and then subtract the shorter hockey. Now then we talked about the exclusion principle, what we discussed, that there's a Venn diagram, this blue zone, blue and yellow zone tells me A unit, event A, and then green and yellow shows me B event. So I say A union B is this, this, this. So I can say, understood? Because if I say A plus B, yellow portion has been added twice. So I must subtract one yellow portion. Right? What do you mean by union? It means when I am saying either or. Either or में add नहीं union करते हैं actually. Getting the idea? Add and union में फर्क है. Right addition is union. Addition में कभी-कभी हम लोग extra add कर लेते हैं 2 बार काउंट करके. तो union क्या करता है? जैसे आप इसको union कहते, अगर इसको addition कहते तो आप क्या कहते? This plus this. आपको लगता है आपने सही ऐड किया है, लेकिन एक्चुअली यूनियन क्या होता है? ये माइनस करना पड़ता है क्योंकि आपने डबल एडिंग कर ली. ठीक है, तो यूनियन इज एक्चुअली द करेक्ट एडिशन. ओके, सो ईदर और वर्ड आएगा तो यूनियन यूज करेंगे. एटलीस्ट वन ऑफ द इवेंट्स, मतलब यूनियन का मतलब क्या हुआ कि इफ आई से ए यूनियन बी यूनियन सी, इट मींस एटलीस्ट ए बी सी में कोई तो होगा ही होगा. 2 भी हो सकता है, 3 हो सकता है. ठीक है, एंड व्हेन आई से इंटरसेक्ट, बोथ द इवेंट शुड बी देयर. Both the events should be there. तो total क्या होगा? Either plus neither will make the, either Jack is in the team or Jack is not in the team. That is the whole thing, right? Either or neither. Either में आ जाता है at least one और neither में आ जाता है none. So this was the story. Then we saw the pattern that okay, if 3 events, then 3 patterns is sigma A minus sigma AB plus sigma ABC. यही था ना? Can you come down? And for D, it was sigma A minus sigma E, sigma AB plus sigma ABC minus ABCD, right? And for 5, sigma A minus sigma AB plus sigma ABC minus sigma ABCD plus ABCDE, right? So in this exercise, we gave the 6th part. So which of them will have negative? So 6C2, second, sigma A won't have any positive terms. Sigma 2 will be positive. So 6C2, 6C4 and 6C6. Okay. So find the number of ways. Okay. Then we also understood what does it mean by using that principle only, exclusion principle only. We understood AB जब together होगा तो क्या होगा, CD जब together होगा तो क्या होगा, एंड में दोनों इंटरसेक्शन हो जाएगा, और में इन दोनों को ऐड कर देंगे, नीदर में टोटल में से ये माइनस कर देंगे, ऐसे ही कर देते स्टोरी। कैन यू कम डाउन? If A and B together, फिर उसके बाद only A, only B, that blue portion and then the green portion. A and B together implies C and D, means the blue portion and the green portion excluding the yellow portion. Can you come down? Next slide, please. So finally we talked about this because of some purpose. We started this journey because of the derangement. Like 6 letters all sent to the wrong addresses. In how many ways I can post my 6 letters to the wrong addresses, deliver my 6 letters to the wrong addresses. That must be some other, वो तरीका हम count करने सीखे थे. So how does it count? लेकिन ऐसे देखे थे. Let's say we have to arrange A, B, C, D such that A occupies the same position. That was 4 factorial. B occupies the same position. That was also 4 factorial. And A and B occupies the same position. That was 3 factorial. Either A or B occupies the same position. 4 plus 4 minus 3. This was the story. Can you go to the next slide? Okay, so either A or B was same. Neither turned out to be. Okay, total minus either. Okay, so none of them, neither A or nor B reached the right position, right? Can you come down? This was the story, either A or B, but not both. We have discussed this. Okay, here comes the tough one. Either A or B or C or D or E. At least एक सही letter पहुंच गया है. At least one letter has been delivered right. So I say A union B union C union D union E means sigma A, मतलब कोई एक पांचों में से कोई एक बंदा पहुंच गया, minus this story starts. Okay, can we go to the next slide? So that was everything. At least one has reached. None has reached means total minus at least one. So we found that 5 factorial minus this. You saw this? Can you go to the next slide? Last slide. Last page. Come down. So this was the story, right? Sigma A is nothing but 5 into 4 factorial. Sigma AB, I chose 2 fellow, put them in the right position. बाकी को shuffle कर दिया. 3 बंदे को चूज किया, सही पोजीशन पे डाल दिया, 2 को शफल कर दिया, 4 को चूज किया, सही पोजीशन पे डाल दिया और 1 को शफल कर दिया. उसको क्या करेंगे, उसी में चला जाएगा. और 5 को किया 0 फैक्टोरियल, राइट? सो दिस वाज द पैटर्न जो माइनस करके आएगा नन. सो एक फाइनल पैटर्न हमें दिखा क्योंकि 5 फैक्टोरियल अपॉन 1 अपॉन 0 फैक्टोरियल माइनस 1. सो ऑल्टरनेटिवली प्लस माइनस और नीचे डिनोमिनेटर से इंक्रीज कर रहा है 0 से लास्ट तक, है ना? अगर ऑड है तो माइनस आ रहा है और इवन है तो प्लस आ रहा है. कैन यू कम डाउन? So I can see a pattern. There you are, and this is called dearrangement, when after shuffling none gets back to its original position. Can we go to next slide? So this was the say I saw the result of dearrangement of 5 object, that was D5. Is 5 factorial is this. So what about the dearrangement of 6? Okay, that will be D6. D6 is going to be 6 factorial into 1 upon 0 factorial minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial, right? Okay, cool. Let me generalize. Dn is n factorial into 1 upon 0 factorial minus 1 upon 1 factorial plus 1 upon 2 factorial. Alternatively, plus minus and ends with minus 1 to the power n, because I don't know whether n is even or odd. If n is even, that will become plus, and if n is odd, that will become minus, and which means shuffling of n objects when none of the object occupy back its original position, right? And the next slide. That was the exercise we did. Can you come down? We also discussed this on1 and on2 function, right? है ना? 3 बंदे सही जगह पहुंच जाएंगे और 7 बंदे डिरेंज हो जाएंगे, है ना? ये स्टोरी होगा ना fx is equal to x की. Okay, next slide. You just see and shuffle it. Pass it on. This was 40. Can you know? This was 44, right? नहीं, वही नीचे के, हाँ वही होगा 43 बैक. Okay, every time a new situation comes and then we figure out how to count them. Now comes the variation in grouping. I'm giving you a situation and it is. Anyone saying something? क्या? नहीं. क्या कह रहे हैं? Mail us this PPT. Okay. I've asked Sushmita ma'am to mail it. Okay. Okay, every time a new situation comes and then we figure out how to count them, right? Now comes the variation in grouping. I'm giving a situation and here it is. You have 3 boxes and you have to distribute 10 chocolates in the ratio of 5:3:2. So you didn't mention whether the boxes are identical or distinct and the balls are identical or distinct. Why not? Let's explore all the possibilities. So first we chose that, okay, balls are distinct, boxes are distinct. Can we come down? Then balls are identical, boxes are distinct. Can we go to the next slide? So we actually did all the permutation combination possible with balls and boxes and distinct and identical. Like that will finally be 4 to the power 2. Two things there, right? That will be 2 to the square. Shareable, hai na? Okay. So the first case was, can you come down? It was balls distinct and boxes were distinct, right? So I can see, okay, I have 10 distinct balls and 3 distinct boxes, and I have to shuffle them in. I have to put them in 5:3:2. So I'm going to select 5, then 3, then 2, and then I can shuffle it 3 factorial. Can we come down? So this is easy, 10C5 here. And so the final answer is this, right? No difficulty in this issue. Can you go to the next slide? 2 balls identical, but boxes are distinct. What? I think. So I chose 5, put it there, 3, 2, एक ही तरीके से होगा, and then I can shuffle them 5, 3, 2 in 3 factorial ways. Can we come down? So the final answer is 1 into 1 into 1 into factorial. Can we go to the next slide? Now you see all are identical. Boxes are also identical and balls are also identical. So I see that, okay, I'm going to choose 5, 3, 2, 1 into 1 into 1. Okay, now shuffling, will it matter? No. So final answer would be 1. Can you come down? Next slide. So now I see 4, this is the 4th number. The balls are distinct, but boxes are identical. So I chose 5 balls, 10C5, I put it here, 3 and 2. Will my shuffling matter? No, because boxes are identical. So I'll say the final answer is, can we come down? 10C5 into 5C3 into 2C2. Now we change thing by the ratio is changed to 6 to 2. 5, 3, 2, all the 3 numbers are distinct. Now here comes the story of 2 of them are same. So can we come down? So when balls are distinct and boxes are distinct, first I'm going to choose the same way, 10, 6, 6, then 4C2, then 2C2. Then I have kept this 6 to 2 in that 3 boxes. Those 3 boxes are distinct, but the ratio is same, right? So 6 to 2 or 2, 6, 2 or 2, 2, 6. Only 3 ways we can shuffle them. Understood? 3 factorial by 2 factorial. Can you go to the next slide? We never have to do permutation. We always have to do combination, and then we can shuffle whatever the question is required to. Now let's say you have 6 to 2. Again, the condition is boxes are distinct and balls were identical, right? So हमने क्या किया? नहीं, ये तो हो गया, नीचे आइए. This is the story. So balls are identical and boxes are distinct. So मैंने balls को choose कर लिया, 6 to 2 डाल दिया, और उसको जब shuffle किया, 3 factorial से shuffle किया, 2 factorial नीचे आ गया, 6 to 2 वही वाली story. Can you go to the next slide? Okay, the third one. Balls are identical, boxes are identical, doesn't matter. 6 to 2 ठीक है, कोई problem नहीं होगा, ठीक है? इसको मत कर देना 1 into 1 into 1 upon 2 factorial. Answer would be half. Half क्या? Half bar होगा. So I have distinct balls and boxes are identical. So I just chose this distinct balls. I put 6 to 2, but boxes are identical. तो जब 6 to 2 है, 2 to 6 है, उसमें कोई फर्क हो रहा है क्या? तो I have to divide everything by 2 factorial. Understood? क्योंकि डबल काउंटिंग हो जा रही थी. ठीक है, ये कॉन्सेप्ट क्लियर हुआ था. फिर हमने क्लियर किया था क्या, चलो यहाँ पे ही देख लो, नीचे आ जाओ. ये स्टोरी दिखाई दी है ना, इन दोनों में एक्चुअली सेम है, हमने इसे 2 काउंट कर लिया है ना, तो उसको हमने ठीक किया बाय 2 फैक्टोरियल डिवाइड करके. कैन यू गो टू नेक्स्ट स्लाइड? Okay, when the ratios have distinct components, you can count and shuffle the way you did. But when it is something like, let's say 6 is to 2 is to 2 is to 2, you have to divide by 3 factorial. Okay, groups, stacks, bundles are considered identical boxes. Can you come down? So this was the exercise. It was talking about distribute a pack of cards in 4 groups. It means 52 distinct cards in 4 same boxes, identical boxes. ठीक है, वो केस हो गया ये. Second is 52 distinct cards, 4 distinct people. वो केस हो गया. Can we come down? Find the number of ways to distribute 10 balls in 4 boxes such that no box is empty. Balls are identical and boxes are distinct. How to go for it? Balls are identical, boxes are distinct. क्या वाला कहानी है, चॉकलेट्स और सीता वाला कहानी है. पहले क्या कर देना है, सब में एक एक चॉकलेट डाल देना है ताकि कोई एम्प्टी ना रहे. तो आपने क्या किया, डाल दिया, फिर उसके बाद होल नंबर सॉल्यूशन निकाल दिया. क्लियर? डालने के बाद कितना बचा, 6 चॉकलेट बचा, फिर उसमें होल नंबर सॉल्यूशन निकालोगे. ठीक है, समझ में आया? उसी तरीके से बॉल्स आर डिस्टिंक्ट एंड बॉक्सेस आर आल्सो डिस्टिंक्ट. फिर इसमें क्या करेंगे, we'll talk about golden ratio when we'll talk about Fibonacci. We are not talking about Fibonacci. When we'll in binomial theorem classes, please again ask me to do this, because we'll, or maybe in the last moment I'll discuss golden ratio. Okay, it's basically, it comes from the Fibonacci numbers. So we'll talk about the golden ratio. Good question. Okay, now the balls are distinct and boxes are distinct. So अगर हम डायरेक्ट कर देते तो क्या आंसर आता है, अगर हम वो रेस्ट्रिक्शन हटा देते, नो बॉक्स इज एम्प्टी, तो क्या आंसर आता है, शेयरेबल टू द पावर अनशेयरेबल, बॉक्सेस आर शेयरेबल, 4 टू द पावर 10 हो जाता है. इसको एक्सक्लूजन से करेंगे, टोटल माइनस एटलीस्ट 1 इज एम्प्टी. एक्सक्लूजन, टोटल माइनस at least 1 is empty will give me none is empty, right? Can you go to the next slide? Now coming up with more variation, let's see the situation. You have 8 अच्छा, you know, we are heading to something जहां हम लोग last time रुके थे. That was a Stirling number. वहीं से हमें पता, आप लोगों ने Stirling number के क्वेश्चंस किए थे, प्रैक्टिस किया था, स्ट्रक्चर बड़ा अच्छा पैटर्न आया जाता. Okay, let's see, करते हैं. So I have 8 chocolates and 3 boxes. Each box has at least 2. Now situation, the chocolates are distinct and the boxes are distinct. क्या करें इसमें, at least 2, we broke the things into the cases, right? है ना, वैसे ही किए थे. Can we come down? This was the story. 2 3 3 and then 2 4 2 and then 2 3 3 had 3 3 ratio, so we managed it out. Again it had, so we managed it out by 2 factorial, right? Can you go to the next slide? When we had boxes are distinct but the chocolates were identical, so we selected the chocolates into this, and then boxes were 3 factorial upon 2 factorial and 3 factorial upon 2 factorial, right? And when chocolates are also identical and boxes are identical, only 2 cases, right? And when boxes are identical but chocolates are distinct, we made it, and then we shuffled into 1 upon 2 factorial. Why 1 upon 2 factorial? We have discussed it. Okay. Another story, same story of 8 chocolates and 3 boxes with the condition that each boxes can have maximum. Again, we broke the things into the cases. Can you go to the next slide? This was the 4 possibilities, right? Maximum 4, we cannot go to 5, 404, 413, 422, 323. इसके बाद नहीं बन पाएगा, है ना? These are the possibilities. तो एक तो हो गया कि हमने चलो डिस्टिंक्ट को सबको चूज किया और फिर शफल कर दिया. जहां पे रेशियो सेम है वहां पे 2 फैक्टोरियल, जहां पे रेशियो सेम नहीं है उसको एज इट इज छोड़ दिया, राइट? कैन यू कम डाउन? सेम स्टोरी, right? Can I go to the third? Okay, this was simple. The simple case, total case बता दो उतना ही हो जाएगा, right? Can I go to the next slide? Okay, the identical story में क्या हो गया था कि we chose and then 1 upon 2 factorial, it remained 1 because it is 413, and then 422 1 upon 2 factorial, and then 332 becomes 1 upon 2 factorial, right? Another situation with a little variation. Oh, okay, can we come down? Some situation of 8 chocolates and 3, but the condition is none of the box remains empty. Now coming to the main thing. Can we go to the next slide? When no box is empty, दोनों distinct है. We have already discussed total weighs minus at least one. So 3 chocolates, three boxes, 8 chocolates. So 3 to the power 8, that is the total case. Minus मैंने एक को empty छोड़ दिया, तो एक को choose करना पड़ेगा empty छोड़ने के लिए, फिर इसको 2 to the power at least one is empty. One of them is empty. 2 empty. वही A union B वाली कहानी चल रही है, right? एक, फिर दो, फिर तीन, right? Clear or not clear? Okay, can we come down? When chocolates are identical, boxes are distinct. 8 है तो सब में एक एक डाल दो. 5 बचा तो x plus x2 plus x3 should be equal to 5. These are the cases. जितना केस होगा उतना आंसर हो जाएगा. Can you come down? Now here the need of thing. अच्छा इसको कैलकुलेट किया था, इसको कैलकुलेट करो, क्या आंसर है बताओ जल्दी. इसको कैलकुलेट करके आंसर नोट करो. हमें चेक करना है कि हमारा स्टर्लिंग नंबर का मेथड सही है कि नहीं. चेक करो क्या आंसर आ रहा है. Okay, first one is 8 into 7, that is 56, divided by 2, 28. तो पहला बंदा हो गया 28. Now 7c2 is 7 into 6, that becomes 21. 21 into 8 is 168. 168 into 50. 10. 10. So 8. Okay, fine. ये भी आगे कितना आया? 210. कितना आया ये? 21 in. Wait. This is 7c2. 7 into 6. 7 into 6 by 2. This is 21 into 8. 168. No, this was just. This is 5c5. This is 1 actually. यहाँ पे गलत लिखा हुआ होगा. हमने सेलेक्ट करना है ना. 5c5 है ये, शायद पेरेंट्स गड़बड़ से आ रहा है या लिखा हुआ है. ठीक है, वही मैं सोचा 1000 कैसे चला जाएगा. 8c1 into 7c3 कितना हो रहा है? 1 6. ये कितना आया? ये कितना आया? ये कितना आया? 7c3, so 4 चला गया. 7 into 3 4 35. 35 into 8 is 280. 280. Now 6c2 8c2 देखो क्या आ रहा है, उसको 2 से डिवाइड कर देना. सी यू हैव टू फैक्टोरियल डाउन हियर. यहां हमने 2 से डिवाइड कर दिया था, इसको भी 2 से डिवाइड कर देना. देखो क्या आ रहा है, टोटल 966 आ रहा है क्या? $420 आ रहा है. टोटल 420 आ रहा है. आई डोंट थिंक सो. 420 नहीं आ रहा है. This is 28 and this is, I need to have pen and paper. 87, that is 28 plus, तुम लोगों से कॉन्फिडेंस मेरा हट गया है. 7 into 6 by 2 21 168. कॉन्फिडेंस खत्म हो गया है. 7 by 7 into 6 into 5, so that 35 into 8 is 280. 420. तुम 420 अभी फाइनल आंसर क्यों बोल रही थी? 8 6 गया तो 28 into 6 आ रहा है. यही आ रहा है ना सबका? और 8c2 क्या आ रहा है? 8 सते 56. 28 into 6 5 4 20 into half 280 है ना? वही तो मैं बोल रहा हूँ, तुम लोग यार क्या हो गया? 168 makes it 176, 196 and 560, 80, 90. I forget now to add 8, 8, 16. I think sin 66 आएगा, देखो है ना? तुम लोगों के साथ मेरा भी मैथ्स खराब हो गया. Okay, so this is the story. 966 आया, right? Okay, इसलिए अकेले explain the selection when it is multiplied. See, when we are actually, let's say 622, and then you have 262, and you have 226. This is only the three arrangement you can do. That is why 3 factorial needs to be divided by 2 factorial. And that is why we are dividing it by 2 factorial, which we learned in the last cases only. If you missed the track, please go to the PDF and again see the thing. Can you go to the next slide? So finally, that was messy, and I have got a good news for you and a better way. And ये याद रखना आंसर क्या है? 966. Okay, starting line helps to find the number of ways to fill identical boxes. You have identical boxes, and you have to fill it with distinct objects. So when I say NSR, NSR का मतलब क्या होता है? R identical boxes में आपको N distinct और कोई भी box empty नहीं होना चाहिए. Please add on that no box is empty. Can we go to the next slide? So let's explore NSR. When I have to distribute 5 distinct chocolate in 5 identical boxes, I have only one way. When I have to put, I want no boxes to empty, na? So I have only one way. 5s1, well, this is also one. Obviously, एक box है 5 chocolates है, तो पांचों उसमें डाल दोगे. What about 5s10? You have 10 boxes and 5 chocolates. Box खाली रह ही जाएगा. ठीक है, जितनी भी कोशिश कर लो. So here the compilation. Can you come down? NSN is 1, NS1 is 1, and NSR is 0 if R is greater than N. Okay, can we go to the next slide? Here comes a tough one, 10s2. I have 2 identical boxes. I see symmetry between them. So I must break symmetry. So I must, तो symmetry तोड़ने के लिए हमें कोई भी बॉल चूज कर सकते हैं. ये नहीं होगा कि 10c1 से चूज कर रहे हैं, right? As we did in the circular permutation case. So हमने एक उठा के इस पे रख दिया, symmetry तोड़ दिया. अब क्या हो गया मेरे पास? 2 distinct boxes. 2 distinct boxes. 9 chocolates, so I can distribute in 2 to the power 9. लेकिन एक केस होगा जिसमें ये empty रह जाएगा, तो उस केस को माइनस कर दो, तो फाइनली क्या हो गया? 2 to the power 9 minus 1. So 10s2 is 2 to the power. So if I say ns2, it is 2 to the power n minus 1 minus 1. Getting the idea? Can you go to the next slide? So here's another found that ns2 is 2 to the power n minus 1 minus 1, right? Well, you think that it's, here comes a tougher, 10s4. Okay, so 10s4 कैसे किया था हमने? देखो, 4 boxes पड़े हुए थे. We made कि okay fine, let's say जो हमारा आखिरी चॉकलेट होगा वो आखिरी वाले बॉक्स में जाएगा, और इसने कहा कि नहीं, जो हमारा आखिरी वाला चॉकलेट होगा वो आखिरी अकेला नहीं रखेगा, वो किसी के साथ ही जाएगा. यही 2 केस होगा ना, इसके अलावा कोई केस नहीं हो सकता है. या तो आखिरी वाला बंदा अकेला रह गया, या आखिरी चॉकलेट जो है किसी के साथ ही रहेगा, यही केस होगा. तो मतलब आखिरी वाला बंदा अकेला रह गया, मतलब हमने फर्स्ट 3 बॉक्सेस में 9 चॉकलेट्स डाल दिए, NS3. इस तभी ना इसमें डाला ये, तो NS3 हो गया ये. और ये क्या किया हमने कि हमने ऑलरेडी पहले 9 चॉकलेट्स को फिल कर दिया है, तो लास्ट वाला बंदा इज कंपेल्ड टू गो विद समवन, क्योंकि ऑलरेडी सारे बॉक्सेस फिल्ड हैं. So I can say 10s4 is equivalent to 9s3 plus 9s4 into 4. See? Clear? Can you go to the next slide? So are you talking about recursion by any chance? Yes, we see the recursion because बड़े term से छोटा term पैदा होके आ गया. So can we see? Can we come down? So I can say NSR is n minus 1. So I got something called NSR is equal to n minus 1 SR minus 1 plus R into. अगर इसको भूल जाओ तो कैसे याद करोगे? इसको भूल जाओ तो कैसे याद करोगे? 10s4 से, है ना? 10s4 से डिराइव कर लोगे, कहानी आ जाएगी याद. ओके, कैन वी गो टू द नेक्स्ट स्लाइड? Okay, let's do that question. 8s3. Okay. जब तक ये स्लाइड खोज लेंगे तब तक हम लोग 8s3 सॉल्व कर देंगे. What was the recursion we got? NSR is equal to n minus 1. ये आया था ना? Okay, 10s4 is 9s3 plus 4 into 9s4. Very good. ठीक है, this was the story. I had to find 8, 3. That was the story. So I can write 7s2 7s3, which I can write 2 to the power 6 minus 1 plus 3 into 2 to the power 5 minus 1 plus 3 square तो ये 0 हो जाएगा फाइनली. ये होगा आंसर. सी द पैटर्न. 2 to the power 6, ये 3 to the power 0 से स्टार्ट हो रहा है. देखो ये स्टोरी होगी ना. ये समझ में आया कि नहीं आया? नहीं आया समझ में? सबने घर पे किया था कि ऐसा पैटर्न आ गया था? नहीं आया था ऐसा पैटर्न? देखो 3 into 7s3 क्या? 7s3 क्या बन जाएगा? 6s2 plus 3 into 6s3. तो 3 ये तो अकेला 3 के साथ ही आ जाएगा, फिर उसके साथ 3 स्क्वायर बन जाएगा ना. फिर वो जनरेट करेगा 3, फिर वो जनरेट करेगा 3, फिर वो जनरेट करेगा ये. ऐसे ही चलाएगा ना. 3s3 पे फाइनली स्टॉप कर जाएगा क्योंकि फिर 2s3 आएगा तो 0 बन जाएगा. क्लियर? यहां तक कोई प्रॉब्लम नहीं है? चलो इसको सॉल्व करते हैं. तुम लोग मत करना. So this is 63 plus 93 plus this is 15 into 9, 135 plus 27 into 7, 9, 81 into 3, 43 plus 243. So this is 486. This is 93, 96, 156. This is 135. आ गया सेम आंसर. यही था ना? Which one, Mr. Katyar? Miss Katyar? Which one? The whole story 8s3 or the NSR? So we saw the recursion in NSR, that was n minus 1 SR minus 1 plus R into n minus 1 SR. So I can say 8s3 is nothing but 7s2 plus 3 into 7s3, and 7s2 will generate 2 to the power 6 minus 1, and 7s3 will break into 6s3 into plus 3 into 6s. This will generate 6s2 plus 3 into 6s3. तो ये तो बना गया, इसके साथ वो 3 के 3 स्क्वायर बन गया. ऐसे ही जनरेट करता चला जाएगा तो ये पैटर्न आ जाएगा. हर बार खोलने की जरूरत नहीं है, पैटर्न आ ही जाएगा. ठीक है? जब ये पैटर्न आ जाएगा तो आंसर निकाल देना, ऐड कर देना, ये तो ठीक है ना, कोई डिफिकल्ट नहीं है, उससे तो अच्छा है केसेस ब्रेक करो, चूज करो, ऐड करो, इतनी सारी मल्टीप्लिकेशन करो. यू सी द पैटर्न, थिंग्स आर इजी नाउ, एवरीथिंग इज इन पैटर्न नाउ. और घबराओ मत, आईआईटी जेईई में ज्यादा डिफिकल्ट कैलकुलेशंस नहीं आते हैं, वो मुनीम नहीं देखना चाहते हैं कौन अच्छा मुनीम है, दे वांट टू सी कौन अच्छा वो है. Obviously, but it's not like if you are very fast in calculation doesn't mean that you are a munim. It means that numbers fascinate you. Can you come down? So this was nothing but it. Okay, can we go to the next slide? So we have already done that. Okay, I have already solved it. So the person who just saw this, so I see 8 is 3, 8 minus 1. Okay, so it turns out to be 7 is 2 plus 3. Then finally I went to the next step. So I see the patterns are emerging. So finally I made it, right? And then we got the right answer. Right? क्या हो गया? Can you go to the next slide? What is S? S is Sterling number. It's a letter in English language, English alphabet. Now, S is basically, as you remember the last questions, we were discovering the patterns, like we were distributing our chocolates and in the boxes, and we were making sure that the boxes should not remain empty. So we actually saw all the possibilities that when the boxes are distinct and the chocolates are distinct, when the boxes are identical and the chocolates are identical, when the chocolates are identical and the boxes are distinct. And the last case was when the chocolates are distinct but the boxes are identical, how to go for it. So we actually started using the concept of Sterling number, and then we actually saw what Sterling numbers like NCR. We also derived what NSR is. NSR is nothing but number of ways of filling n chocolates in our boxes such that no box remains empty. And then we derived what does it mean when I say 5 is 5, and what does it mean when I say 5 is 1, and what does it mean when I say 5 is 10. Then we come to the result that NS1 is 1, NSN is 1, and NSR is 0 if R is greater than N. Now shifting our attention from Sterling to another number called Pascal's number. Now Pascal number का definition क्या है? Let's see. We understood NCR, we understood NSR. Don't worry, सबसे difficult part handle हो गया है. That was Sterling. Pascal is very easy, very easy. So the good news is the difficult part you have understood. Last time we finished in Sterling only ना. So Sterling में clear है सबको concept या अभी भी पंगा है? Clear है सबको? Okay, good. Now, what is Pascal number? Let's first define it. So I'm going to say Pascal number, ये भी पुराने ही केस से आ रहा है. ये भी पुराना जो identical वाला केस था ना. Boxes also identical and chocolates. तो उसमें भी हम लोग केसेस ब्रेक करते थे ना, सारे डिस्ट्रीब्यूट करके देखते थे, जो हो सकता है एक मिस कर जाए, कभी एग्जामिनेशन टेम्परामेंट हो सकता है मिस कर जाए, मैक्सिमम 4 में एक मिस कर जाए या मैक्सिमम 5 में एक मिस कर जाए, तो उससे भी बचने के लिए वी हैव अ टेक्निक. नंबर ऑफ वेज टू फिल आर आइडेंटिकल बॉक्सेस with n identical chocolates such that no box is empty. So you see, it's basically the third case it's talking about, because chocolates are also identical and boxes are also. n क्या है? Number of chocolates, और r क्या है? Identical boxes है. So here it helps to find the number of, can you come down? So here it helps us to find the number of ways to fill r identical boxes with n identical chocolates, and of course no box should be empty. Can you go to the next slide? Which question? Which question? अभी आप जितने क्वेश्चंस आ रहे हैं उसे आप रख लीजिए, because we are in the verge of completing this permutation combination. So after that we'll discuss that. We have time, right? Good. Can you go to the next slide? So let's explore Pascal number the way we explored NCR, the way we explored NSR. We also explored D5, DR, DN, right? Now it's time to, तो कितने आगे हमारे टेक्निक सारे समझ में आ गए. So permutation combination, I think it's getting easier for you, right? अच्छा आ रहा है, मजा आ रहा है काउंट करने में? Okay. So even after your graduation, let's say you plan for a CAT and all, permutation combination question ऐसे क्लिक करोगे. Okay, now see 5T5. You have 5 identical chocolates, 5 identical boxes. सब में एक एक डाल दो. Easy, very easy. Common sense, which is not so common. So I have already. So I say NTN is 1, NT1 is 1, and NTR is 0 if R is greater than N. Clear? यहाँ तक कोई इश्यू नहीं है. अब तो चलते हैं थोड़ा सा कैलकुलेशन करते हैं. 10T2. Okay. Now let's say 10T2. It means I have to distribute my 10 chocolates in 2 identical boxes. In तो अब यही होगा ना 19, 28, 37, 46, 55. फिर तो नहीं होगा 64. वही चीज स्टार्ट हो जाएगा. तो बेसिकली 5 is ये दिख रहा है. So we saw that 10T2 is 5. 10T2 is 5. Can you go to the next slide? Okay, let's say 9T2. 18, 27, 36, 45. Okay, yeah. Whom लिखा हुआ भी था क्या? Okay, I didn't see that. That was natural, I guess. So 9T2 is 4. So 10T2 is 5 and 9T2 is 4. 8T2 will be 4. 4. 8 देख लो. अभी देखते हैं. 8 है ना? 17, 26, 35, 44. So what we saw? NT2 is greatest integer n by 2, where this denotes greatest integer function. You know what is greatest integer function? थोड़ा बहुत idea है ना? Greatest integer function is something like if I have to find ये जो डब्बा दिखेगा और क्वेश्चनर लिख देगा इस डब्बे को कि ये ग्रेटेस्ट इंटीजर फंक्शन है. इसका मतलब है कि वो बंदे से जो इंटीजर सबसे नजदीक है लेफ्ट हैंड साइड में, दैट विल बी द ग्रेटेस्ट वन, राइट? इफ आई से ग्रेटेस्ट इंटीजर ऑफ 4.5, 4, 5.7, 0.1, 0, minus 1.7, minus 2. You have to see the left side, not the right side. Okay, the greatest part जो greatest integer आपके लेफ्ट में पड़ा हुआ है. Okay, so जब भी आएगा तो सीधे आ जाएगा नंबर. 5 का क्या होता है greatest integer? 5 है ना? 5 का 5, 10 का 10, समझ में? और 10T2 का 5 हो जाएगा, 20T2 गया 10 हो जाएगा. अब देख लो सेम स्टोरी है. अच्छा, इसका बताओ मुझे. 21T2 का 10. वेरी गुड. Now comes the tough one. Next slide. 10T4. 4. See, when I say okay, यहाँ तक ठीक है ना? Okay, now 10T4, I say at least one ball is lonely, no ball is lonely. When I say one ball is lonely, it means मैंने 3 में हो सकता है इसमें कोई एक बंदा लोनली यहां पे भी हो, एटलीस्ट है ना? तो एटलीस्ट मैं एक को श्योर कर दिया और बाकी को 93 से डिस्ट्रीब्यूट कर दिया. सो आई कैन से 93 प्लस 64, क्योंकि मैंने सब में एक एक डाल दिया. अब कोई लोनली नहीं बचेगा, है ना? सब में एक एक डाल दिया तब कोई लोनली नहीं होगा. कोई बॉल, वो कौन सा गाना था? लोनली वाला गाना था ना कोई, तो वो कोई ऐसा गाना नहीं गा पाएगा. सो एवरीवन विल हैव वन. उसके बाद अब तुम 6 डालोगे तो ऑब्वियसली एक बंदा तो चला ही जाएगा ना, एटलीस्ट एक के पास, तो 2 ही हो जाएंगे ना. तो आई कैन ब्रेक माय 10T4 केस इन एटलीस्ट वन इज लोनली, नो वन इज लोनली. यही केस होता है ना, एटलीस्ट वन और नीदर मेक्स द टोटल केस. सो आई कैन ब्रेक 10T4 इन 93 plus 64. Again we saw recursion. What is the recursion here? n minus 1 tr minus 1, एक बॉल जिसको एटलीस्ट वन बॉल इज लोनली कर दिया, प्लस सब में एक एक डाल दिया, मतलब जितने बॉक्सेस थे उतने बॉक्स निकाल के सब में डाल ही दिया, तो n minus r tr. तो ये रिकर्शन समझ में रहेगा. So I can say NTR, एक बॉल को लोनली कर दो, यही हुआ था ना, एक बॉल को अलग लोनली बना दो, फिर किसी को लोनली मत करो, यही था. Now let's say I have to find 8 चॉकलेट 3 बॉक्सेस, 5 आंसर आया था ना, याद है? इसका भी 5 आ रहा है, देखो 83 कैन बी रिटन एज 72. 8 minus 3 is 8 minus 3 is, so what is 72? 7 by 2. Now 5t3 can again I can do 42 plus 2t3. This will become 3, 42 will become 2 and this will become 0. पास्कल नंबर अच्छा लग रहा है ना? स्टर्लिंग नंबर थोड़ा गंदा था. Okay. Here comes the exercise and PNC is over. We'll do some question, of course. We'll discuss some questions now. So first do this exercise. So you understand the Pascal number, you understand the Stirling number, you understand NCR. We'll discuss first these 2 questions and then I'll put 2 questions here more, and then I have 25 questions objective. We'll see that also, and after that we'll discuss whatever the questions have been asked, or else we'll discuss. You have finished sequence series at all, na? Okay, we'll discuss some questions from sequence series like we discussed from straight lines, right? So we always straight some time. This is the last class of PNC, na? Okay, so we have finished before time. In fact, finish तो कल last time हो गया था, बस Stirling और Pascal बचा था, and you don't find it in any book. Do you find? But questions come, and you solve it through that long method, traditional way of counting. So let's do this question. 10 chocolates are to be distributed in 4 boxes. All chocolates must be kept in these 4 boxes. मतलब 10 chocolates में 10 chocolate distribute होने ही हैं. Box can remain empty. ऐसा नहीं है कि box empty नहीं छोड़ सकते हैं. Find the total number of ways. Okay, इसका आंसर बताओ जल्दी से. Shareable to the power क्या हो जाएगा आंसर? 4 to the power 10. Very good. इसका क्या हो जाएगा? Chocolates are identical, boxes are distinct. कैसे करें? हाँ 4. आप वैकेशन से आए हैं और आपके पास 10 चॉकलेट्स हैं और आप अपने 4 दोस्तों को भेजना चाहती हैं, फिर आप 4 फैक्टोरियल होल नंबर सॉल्यूशंस फ्लैग्स लगा दो. 10 चॉकलेट्स के बीच में 3 फ्लैग्स डाल दो. 13 फैक्टोरियल बाय 10 3. Now this one, chocolates are identical, boxes are identical. Boxes can remain empty. तो क्या होगा? अब देखो यहां पे कैसे करेंगे. You have 10 chocolates और identical, दोनों identical है. किसकी बात करेंगे हम? मिस्टर पास्कल नंबर. तो कितने बॉक्सेस हैं हमारे पास? 4 बॉक्सेस हैं. कितने केसेस हो सकते हैं? नो बॉक्स एम्प्टी, 1 बॉक्स एम्प्टी, 2 बॉक्स एम्प्टी, 3 बॉक्स एम्प्टी. वो तो नहीं होगा. होगा भी तो 0 आ जाएगा, है ना? अगर लिखोगे भी तो 0 आ जाएगा. तो आई कैन ब्रेक माई थिंग्स इनटू 10 चॉकलेट्स है ना, 10 T4 राइट. 10 चॉकलेट को एक बॉक्स में कैसे डाल सकते हो? 10 आइडेंटिकल चॉकलेट्स को एक बॉक्स में कैसे डाल सकते हो? T3. अब देखो दोनों को मैं चेन अप कर रहा हूं. 10T3 can be broken in one ball. 10 minus 3 is ये हो गया. अब इसको फिर से ब्रेक कर दो. इसको ये क्या होगा, ब्रेक करके क्या देगा मुझे? इसको ब्रेक कर दो. सॉरी, ये आ गया. इसको ब्रेक करो. प्लस जो हो गया 0. So now I know my 92 is 4 plus my 62 is 3 plus my 322 is. ठीक है, देखो पास्कल नंबर कितना हेल्प कर रहा है हमें. Now 24. अब इसको ब्लू आ गया है क्या? नहीं. Okay. Now 24 can be broken into 64. 93 देखो क्या ब्रेक करेगा? 82. फिर 63 कैसे ब्रेक करेगा? So I got this. देखो ये भी बचा हुआ है. 64 कैसे ब्रेक करेगा? 6 minus 4 is, ये तो खत्म हो जाएगा खेल. 5T3 कैसे ब्रेक करेगा? 42. खत्म खेल. तो ये हो गया. देखो कितना आसानी से हो रहा है, बस पेशेंस चाहिए है ना. 4 2 1 2. So answer is 4 3 7 8 13 14 18 20 21 23. Getting the idea? Mr. Pascal really helped us, huh? It turned video. Okay, what video interaction? Okay. Okay, the person wants to come on the screen. Okay, Miss Katyar. Okay, it's the name of the student or the coordinator? Coordinator. I should face the camera. Okay. Yes. I want to see the face. The person who is asking. Okay, where is the person? I think network issues, right? Okay. When we get the connection, we'll talk. We can proceed? Okay. Where were we? Identical. Now comes the difficult one. Mr. Sterling. Now what will be the answer for the D part? I can have an empty box, right? I can have an empty box, so I cannot put directly 10 as 4, but rather the answer would be ये तो तुरंत सॉल्व हो जाएगा. ये भी तुरंत सॉल्व हो जाएगा. देखते हैं कैसे. 10 is 3. Can you broken into ये तो हो गया. तो फाइनल आंसर ऐसा ब्रेक करेगा 2⁸ - 1 + 3 into dot 3⁻⁻1 to 6 to 7. ये हो जाएगा ना. कर लेना कैलकुलेशन क्या आता है. ठीक है. नाउ 10 is 4, 9 is 3 + 4 into 9 is 4. अब देखो जो पैटर्न क्रिएट होगा ना वो ये कुछ ऐसा होगा. 9s3 का तुम्हें स्टोरी पता है ना. 9s3 की स्टोरी वैसी ही हो जाएगी जैसे वो हुई थी, है ना. उसी तरीके से यहाँ पे 4 के साथ स्टोरी स्टार्ट हो जाएगी. ठीक है. सो घबराओ मत, ऐसा क्वेश्चन नहीं आएगा, इतना कैलकुलेशन कराने को नहीं आएगा. और अगर क्वेश्चन आएगा भी, फिर राइट द आंसर दिस वे ऑप्शंस में. ओके. वो और अगर ऐसा आता है, अगर पूछ भी लिया, छोड़ देना क्वेश्चन. ठीक है. बिकॉज दे आर गोइंग टू कंज्यूम द टाइम. ठीक है. अगर वो पूछेगा तो सिंपल ऐसा ही पूछेगा या एक बंदे को पूछेगा. अगर बहुत ज्यादा तुम्हें वो तंग करना चाहता है, मान लो क्वेश्चन पेपर बनाने से पहले उसकी लड़ाई हो गई थी घर पे, तो वो अपना गुस्सा बच्चों पे निकालना चाहता है तो वो ये दे देगा, बहुत ज्यादा गुस्सा आया तो. ठीक है. तो निकाल लेना आराम से, सर कूल करके. ठीक है. ओके. यू नो द मेथड, राइट. ओके. नाउ द क्वेश्चन इज द सेकंड पार्ट. देयर वाज दैट ऑल चॉकलेट्स टू बी डिस्ट्रीब्यूटेड. आपने 10 चॉकलेट खरीद के लाई थी घर बाहर से, अब वो देना ही था, सबको डिस्ट्रीब्यूट करना था. अब है कि कुछ अपने पास भी रख सकते हो. तो नाउ द बॉक्सेस हैव टर्न आउट टू बी 5. तो अब ऊपर जाइए. तो अब क्या हो गया, ये 5 हो गया. पहला का आंसर हो जाएगा 5⁻10. इसका होल नंबर वाली कहानी और इसकी पास्कल नंबर की कहानी उतने केसेस में प्लस 10t5 + 10t4 + 10t3 + 10t2. पास्कल नंबर तो उतना आसान है, वो तुम्हें तंग नहीं करेगा ना. 10s5 तंग करेगा. कोई बात नहीं, आंसर 10s5 ही होगा. छोड़ देना, निकालना मत. ओके. नाउ कैन वी कम डाउन टोटल. ओके. दिस इज द क्वेश्चन. सोच रहे हो कि हमेशा फंक्शन का एक क्वेश्चन आ जाता है परम्यूटेशन कॉम्बिनेशन में. सो हाउ मेनी फंक्शंस आर पॉसिबल इफ, so I've given all the cases A, B, C, D, E, F, 1 1 on. We have talked about this, right? What is 1 1 function? What is onto function, into function? अच्छा, फंक्शन या तो 1 1 होगा या तो मिनी 1 होगा या तो onto होगा या तो मतलब अगर मैं 1 1 निकाल चुका हूं और मैं टोटल निकाल चुका हूं तो मिनी 1 सिंपल माइनस हो जाएगा. और अगर मैं टोटल निकाल चुका हूं और onto निकाल चुका हूं तो इनटू बस माइनस हो जाएगा. तो मेरा आइडिया है जस्ट टू फाइंड 1 1 onto and total. ये तीनों निकाल देंगे, कहानी कितनी हो जाएगी. अब कंडीशन क्या है, Na is 3, Nb is 4. Na is 3, Nb is 3. Na is 4, Nb is 3. मतलब ये स्टोरी है. फर्स्ट है Na3 ठीक है. ये ब्लैक वाला A है, रेड वाला B है. ठीक है. यहाँ पे मैं टोटल नंबर ऑफ फंक्शंस लिख रहा हूँ. टोटल फंक्शंस विदाउट रेस्ट्रिक्शन 1 1 onto anyone into bijective. यही कहानी है. Okay. Now this is your three fellows who wants to go into four fellows. फंक्शन की कहानी क्या होती है? ये दो बंदों के पास नहीं जा सकता है. तो which is non-shareable here? This is non-shareable here. इस हर एक बंदे के पास कितने चॉइस है? तो क्या आंसर होगा? Shareable to the power unshareable. Very good. Now you have three fellows. Again, this is non-shareable and this is हर बंदे के पास क्या ऑप्शन है? थ्री ऑप्शन है. क्लियर? टोटल फंक्शंस में तो बहुत कोई प्रॉब्लम नहीं हुआ है ना. लेट्स सी 1 1. Now 1 1, I just need one correspondence with this, one correspondence with this, one correspondence with this. तो इसमें मैं कितने बंदों को चूज करना पड़ेगा मुझे? 4c3. और कितने तरीके से मैं इन लोगों को पेयर बना सकता हूँ? 3 factorial. So I can say 1 1 is ठीक है. Now look here. ये ठीक है ना? 3 चूज कर दिया और कर दिया. अब ये देखो 3 बंदे हैं और ये 3 पक्का 3 को अलग ये करना होगा. 1 1 है ना? I need one correspondence only. कैसे होगा ये? 3 factorial से. Now here I want to create a 1 1. ये अकेला रह जाएगा. पॉसिबल है? Clear or not clear? Clear. Very good. Now come to the onto part. Onto means all to be used up. Now 4 chair to be filled by 3 person. It will always remain one empty. तो ये हमेशा कभी onto नहीं बन सकता है. ये कैसे बनेगा onto? अगर वो 1 1 है तभी onto बन पाएगा. ठीक है. Now comes this. 4 बंदे. Okay, let's do this way. 4 letters, 3 boxes. है ना? 4 letter, 3 boxes. ठीक है. I don't want any box to be empty. I don't want any box. तो total case minus at least one is empty. Total case minus at least one is. देखो मैं इसको थोड़ा बड़ा स्पेस लूंगा इसके आंसर्स के लिए, इसके लिए. तो पहले मैंने टोटल नंबर ऑफ फंक्शंस कितने पॉसिबल है विदाउट रेस्ट्रिक्शन, है ना? हर एक बंदे के पास 3 ऑप्शन माइनस एटलीस्ट वन इज एम्प्टी. एक बंदे को चूज कर लिया एम्प्टी करने के लिए, एक चेयर को, एक चेयर ही को चूज करेंगे ना, उसको खाली छोड़ दिया. और बाकी सब में कितने को चढ़ाया? टू द पावर 4 माइनस 2 को खींच लिया और बाकी सब में ऑब्वियसली 2 को खींच लिया तो एक ही में सब जाएंगे. ऐसा हो ही नहीं सकता है ना? तीनों को खाली रखोगे तो भाई बैठेगा कहां? ठीक है. तो फाइनल आंसर क्या हुआ? 3 to the power 4 माइनस दिस. समझ में आया? ये अल्टीमेटली प्लस हो जाएगा और ये माइनस बन जाएगा. क्लियर? ओके. नाउ अब क्वेश्चन आसान हो चुका है. ओके. I just wanted to talk that let's say you have to create onto functions, right? Onto functions का मतलब क्या होता है? Your codomain should be equal to range. So you want these 3 elements to be used up. इसको खाली नहीं छोड़ना है. So 3 boxes, 4 letters. You want every box should have at least 1 letter. At least 1 letter, right? So what you say that okay, total case without restriction is 3 to the power 4. Now you say कि अच्छा चलो एक at least one is empty. At least one is empty. Exclusion principle. तो मैंने 3 to the power 4 टोटल केस माइनस एट लीस्ट वन इज एम्प्टी को ब्रैकेट में डाला. तो मैंने 3 में से एक बंदे को चूज कर लिया कि भाई तू एम्प्टी रहेगा. तो बाकी 2 में सबको भर दिया. कितने तरीके से भर सकता हूं? 2 to the power 4 से. फिर मैंने 2 को चूज किया कि भाई तू 2 एम्प्टी रहेगा. तो -3c2 और बाकी सबको 1 to the power 4. फिर प्लस 3c3 0 to the power 4. Clear or not clear? Clear. Very good. Now, since we know total, many one will be, if I call this as A and this as B, answer would be A minus B. I'll call this as C. इसका भी हो जाएगा A minus B. इसका भी हो जाएगा A minus B. ठीक है? Into A minus C, A minus C, A minus C. Clear? Now the question comes bijective. Bijective क्या होता है? जब फंक्शन 1 1 भी हो और on to भी हो, दोनों केस होना चाहिए एक साथ. एंड कंडीशन. इसमें 1 1 तो बन रहा है लेकिन on to नहीं बन रहा है, तो बाइजेक्टिव होगा ही नहीं कभी. दोनों केस पॉसिबल होना चाहिए. इसमें 1 1 भी 3 फैक्टोरियल ऑन, तो कितने होंगे बाइजेक्टिव? यहां 1 1 0 है, ऑन टू जो भी आया ये आया. क्लियर और नॉट क्लियर? क्लियर. नाउ I'll just add one question. I couldn't write it, I didn't get the time. The question is, let's say you have a polygon. Let's say you have a polygon of 10 sides. So basically it's called decagon. So you have a decagon. You want to create a quadrilateral out of this 10 vertices. You have 10 vertices? Which one? I am just giving you the question and I'll explain her after that. The question is, you have a decagon, the 10-sided polygon. You can see 10 vertices. So you have to create a quadrilateral, right? You have to create quadrilateral. You have to tell me, find the total number of quadrilaterals which will have no common side with the decagon. Which will have no common side with the decagon. Please go on. What is the question, please? What's the query kya tha? Now we want to interact with the teacher, so please, let's interact. Should I have to face this way or this way? This way. Okay. But how can I? Yeah, please go ahead. Your question, ma'am. आप लोग क्वेश्चन करें. Do not watch this. Start doing this questions. So you understand the situation that you have 10 sides or 10 vertices. सबसे पहले बताओ total number of quadrilaterals कितने बनेंगे? Without any restriction? 10c4. Very good, very good. And what about the no common sides? So at least we can get 1 common side, then 2 common side, then 3 common side. Total case minus this, we'll get no common side. What is S? Actually we developed S as a Stirling number in which we defined that if I called NSR is nothing but the total number of ways I can distribute my n distinct chocolates in R identical boxes such that no box is empty. यही था ना Stirling number? Okay. What about S? प्लीज आप एक बार पीपीटी जाएं, फॉलो द पीडीएफ, इट्स वेरी इंटरैक्टिव. आई हैव created thinking that all only in mind because we people we have to cover very big things in a very small period of time. That is why I made the interactive PDF, so that when you go back to your place and watch those textbooks, you will be able to interact with the teacher virtually, of course, and you will be able to understand what I want to say. Please ask your coordinator to provide you the copy of the PDF which we are discussing. The whole it has total 69 pages, right from 1 to 69 pages. Please ask your coordinator to get these copy of permutation and combination, 69 pages. Where is the original copy? How was it? You enjoyed? It's fun? Good. अब हो जाए तो मुझे इधर के बच्चों को दिख गया? No? Then why are you not sharing? Non-shareable. Pass it on. So this is the way I'm creating everything. The binomial theorem will be the same pattern. And then whatever the upcoming topics will be. Okay, so you'll be able to enjoy mathematics. I'm trying to make something which can be enjoyed, not something which needs to be afraid of. Math is basically a four-letter word which people are afraid of, right? But that's not the actual story. We are enjoying, right? We enjoyed circle, we enjoyed trigonometry, and we enjoyed this also. We enjoyed even the straight line portion in a very short span of time. We enjoyed locus also, so it was not boring, was it? It was boring. No, it was fast. No. Yeah. So did you do that question? I'm writing two questions more here. After that, can focus it here so that the people at the other centers also note it down. First, please note it down these questions, these 3 questions. I'm just repeating if it's not very clear for the people. I'm just repeating the questions. It says there is a additional questions which I'm writing it. Question number 1 says that find the number of quadrilateral you can form from a given decagon. Decagon is nothing but a polygon with 10 sides, such that the quadrilateral has no common side with the decagon. The second question reads that 20 people are standing in a straight line. Find the number of ways to choose 4 people such that no 2 of them are together. The third questions are 20 people are standing in a circle. Find the number of ways to choose 4 such that no 2 of them are together. Clear? This is the question. Please note it down and then we'll discuss the question. After that, we have 25 questions now. वो interaction वाला क्या हुआ? Net disconnection. Okay. Everybody wrote it down? No? Please wrote it down. It's clear now? Even in the different centers, it must be clear? It must be clear. यहाँ से तो पता नहीं चल रहा है. Okay, so it's clear. Where is your attempt? Why? Talking. अभी तक आप लोग क्वेश्चन लिखे हैं? Where is that? Attempt. I cannot see any attempt. इतना ज्यादा नहीं आएगा. आपने अटेम्प्ट किया? नहीं? Okay. Everybody noted down the question? Okay. Now let's say decagon means it will be something like, okay, you have cluster of 10 points on the plane A1, A2, A3, A4, A5, A6, A7, A8 A9 A10 कुछ ऐसा ही बनेगा डेकागन, राइट? वो ज्वाइन कर दोगे तो बन जाएगा वैसा, कोई इशू नहीं है. सो दिस इज योर डेकागन. सो टोटल नंबर ऑफ क्वाड्रिलेटरल कितने होंगे? 10C4. ये तो क्लियर है, ठीक है. नाउ I want only one common side. What I want? Only one common side. तो one common side का मैं यहाँ पे काउंटिंग स्टार्ट कर रहा हूँ. One common side मतलब you have 10 points, 10 sides. तो 10 sides में एक साइड चूज करोगे, कितने तरीके से चूज कर सकते हो? 10C1 तरीके से आपने एक साइड चूज कर लिया. Let's say I have chosen A1 A2. Right? I have chosen. I'm putting only one common side. I'm not saying any two common sides, right? Only one common side. So can I choose this now? No. Can I choose this now? No. I cannot choose this and I cannot choose this. I can choose this. If I choose this vertex, I cannot choose this. But I can choose this. कितने चूज कर सकते हैं? 1 2 3 4. तो 4 तो हो गया, 4 तो दिख गया. अगर मैं A1 A2 चूज करने के बाद, ये दूसरा स्टेज है, मतलब आई एम चूजिंग द अदर टू वर्टिसेस, तो एक इसको चूज करने पे मुझे 4 ऑप्शंस दिखे, ठीक है. व्हाट इफ आई चूज 8? इफ आई चूज 8 आई कैन नॉट चूज दिस. ये तो कभी नहीं चूज कर सकता हूं. 8 है, A7 नहीं चूज कर सकता हूं. आई कैन चूज 6 5 4, ठीक है. सिमिलरली if I choose 7, I cannot choose this. I can choose this, but I have already counted it. I have already counted everything, right? So यहाँ से आप देखोगे 6 नहीं चूज, A5 और A4, बस यही दो चूज कर सकता हूँ. If I choose this, लेफ्ट साइड ऑलरेडी काउंट हो चुका है, इसे ध्यान ही नहीं देना है. ये नहीं चूज सकते, ये चूज कर सकते हैं. बस इतना ही कहानी हुआ. A5 का काउंट कहानी स्टार्ट हो चुका है, ऐड ऑन हो चुका है. तो 10 चूज करने के बाद टोटल कितने तरीके से चूज कर सकते हैं? 10. तो ओनली वन कॉमन साइड कितने हो गए? 10C1 into 10, that is 100. 3 common sides. थ्री कॉमन साइड्स कैसे चूज करेंगे? एक ये बन गया क्वाड्रिलेटरल, कुछ चूज करने की जरूरत ही नहीं है. ऐसे करके मैं कितना चूज कर सकता हूं? 10. सिर्फ 10 ही चूज कर सकता हूं. समझ में आया कि नहीं आया? ये नहीं समझ में आया? देखो, 3 कॉमन साइड्स, आप ऐसे ही 3 कॉमन साइड चूज कर सकते हो ना. अगर आप कॉन्जिक्यूटिव ही चूज कर सकते हो. अगर आप एक को अलग रखोगे और दो को अलग रखोगे तो पेंटागन बन गया. तो अगर तुम्हें 3 कॉमन साइड्स चूज करना है तो इट हैज टू बी कॉन्जिक्यूटिव. और कॉन्जिक्यूटिव होगा तो A1 A2 A3 A4 या A2 A3 A4 A5 या A3 A4 A5 6. ऐसे करते हुए जाओगे कहां तक आओगे? A10 A1 A2 A3. कितने हो गए? 10. तो ओनली 3 कॉमन साइड्स कितने हो गए? 10. नाउ कम द डिफिकल्ट वन. We broke the cases into ना all 1 3 2. मैंने जानबूझ के बाद में रखा क्योंकि वो डिफिकल्ट है. डिफिकल्ट क्या है? उसमें 2 केसेस हैं. ओनली 2 कॉमन साइड्स. इसके अंदर भी 2 केस आ जाएंगे, कॉन्जिक्यूटिव, नॉन कॉन्जिक्यूटिव. Get the idea? Consecutive and non-consecutive. Now see. ठीक है. अब हमें टू कॉन्सेक्यूटिव साइड चूज करना है। टू कॉन्सेक्यूटिव साइड कितने तरीके से चूज कर सकते हैं? 10 तरीके से चूज कर सकते हैं टू कॉमन साइड्स। तो मैंने 10, लेकिन अभी क्वाड्रेटर बना नहीं है। 3 कॉन्सेक्यूटिव साइड्स चूज करते ही क्वाड्रेटर बन गया था, अभी नहीं बना है, तो मैंने ये चूज किया। ठीक है, आई हैव चोजन दिस, बट अब मुझे क्या एक वर्टेक्स चूज करना है। वर्टेक्स चूज करते ही मेरी कहानी खत्म। आई कैन नॉट चूज दिस, आई कैन नॉट चूज दिस। कैन आई चूज 5? कैन आई चूज 6? कैन आई चूज 7? कैन आई चूज 8? कैन आई चूज 9? यस, वी कैन चूज। सो कितने तरीके हो गए? ठीक है, देख रहे हैं? क्लियर और नॉट क्लियर? अब बस ये बचा है नॉन कॉन्सेक्यूटिव वाला। Which one? Only 2 common sides. See, only one common side was 10c1 into 10. That was clear. Only 3 common side was 10. That was also clear. Now 2 common sides has 2 cases, whether they are consecutive or non-consecutive. If I say they are consecutive, I can choose my 2 consecutive sides in 10 ways. So I chose that. Now the second stage is I have to choose the fourth vertices. So fourth vertices I cannot choose A4. I cannot choose A10. I can choose this 5. So I can say 10 into 5. Clear or not clear? Clear. So 10 into 5, it's an issue, no issue. Now the third, the last case, जिससे फाइनल आंसर आ जाएगा, है ना? नॉन कॉन्सेक्यूटिव साइड्स। मतलब पहले तो हमने एक साइड चूज कर लिया, एक साइड हमने चूज कर लिया। कितने तरीके से चूज कर सकते हैं? ठीक है, हमने A1 A2 चूज कर लिया। अब देखो क्या क्या चूज नहीं कर सकते। ये नहीं चूज कर सकते कभी, ये नहीं चूज कर सकते हैं। ठीक है, फिर ये कर सकते हैं, ये कर सकते हैं। ठीक है, या ये कर सकते हैं, या तो ये कर सकते हैं, या 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 ये कर सकते हैं। यही कहानी है ना। टोटल 5 ही साइड चूज कर सकते हैं, क्योंकि ये साइड अब चूज नहीं कर सकते। ये साइड चूज करते ही कॉन्सेक्यूटिव 3 बन जाएगा। तो ओनली वी कैन चूज 5। तो आई कैन से 10 into 5। लेकिन एक हमने डबल काउंटिंग कर दी। जब मैं 10 साइड चूज किया था, मैंने कोई भी एक साइड चूज किया था, तो लेट्स से A1 A2 A8 A7, और जब मैं A8 A7 चूज करूंगा तो फिर से मैंने A1 A2 ऐड कर दिया, तो मैंने डबल काउंटिंग कर दी है, डिवाइड बाय 2। तो क्या हो गया टोटल? 10C4 का आंसर क्या आया था? So 10 into 9 into 8 into 7 by 24, 210। टोटल क्वाड्रेटर्स कितने बने? 210। वन कॉमन साइड है 100, ये है 10, ये है 50, ये है 25, मतलब 75 प्लस 10 इज 85, 185, 185 minus 210, so there are 25 quadrilaterals with no common sides. Clear? Actually क्वेश्चन इससे आसान आता है, मैंने सबसे डिफिकल्ट वाला दे दिया था, इसमें थोड़ा ज्यादा कैलकुलेशन है। पेंटागन हेक्सागन रहता है, डेकागन नहीं रहता है। ठीक है, तो पेंटागन डेकागन ये सब तो पेंटागन हेक्सागन तो बहुत आराम से हैंडल कर लोगे। क्लियर? ट्रायंगल्स बनाना होगा तो ट्रायंगल्स बना दोगे। क्लियर? Now the second question which I wrote was 20 fellows were standing in a straight line, right? The question was 20 fellows were standing in a straight line. Find the number of ways that 4 we can have to choose. जैसे देखो 20 बंदे खड़े हैं यहाँ पे, ऐसे 20 बंदे खड़े हैं, ठीक है, ऐसे 20 बंदे खड़े, क्लियर, एंड आई हैव टू चूज 4 फेलो सच दैट नो 2 ऑफ देम वर टुगेदर। तो मान लो मैंने चूज किया ये ये 20 बंदों में ये 4 बंदे हो गए, इधर बंदे खड़े थे एक्स ए, इधर बंदे खड़े थे एक्स बी, इधर बंदे खड़े थे, इधर बंदे खड़े थे, इधर बंदे खड़े थे एक्स ई। ठीक है, पहले 4 बंदे तो कैसे चूज करोगे तुम? 20C4, 20C4 से कोई भी 4 बंदे कर लोगे। अब देखो क्या हो रहा है, एक्स से एक्सट्रीम बंदे भी चूज कर सकते हो, बट इट हैज टू बी पॉजिटिव, इट हैज टू बी पॉजिटिव, इट हैज टू बी पॉजिटिव एंड इट हैज टू। तो क्या कंडीशन हो गया कि वी हैव, ठीक है, सो वी हैव 20 फेलोज स्टैंडिंग, 4 वर, we have chosen 4, any 4 can be taken care, matlab basically it becomes they become the flags. Now what will be the story? xa plus xb dash plus 1, clear? Why xb dash? Good. Plus 1 plus xd dash plus xe, क्योंकि 4 बंदे तो चूज हो गए। नाउ थर्टीन हो गया ना? ओके, सो आंसर वुड बी 13 plus 4 minus 1 16C3, clear? Not clear? देखो 20 बंदे खड़े हुए हैं ऑलरेडी, ठीक है, तुम किसी में भी अपना हाथ रख सकते हो। 4 बंदों पे हाथ रखा गया, अब वो 4 में जो 16 बच्चे हैं वो ऐसे ही डिस्ट्रीब्यूट हो जाएंगे ना। तो हमारी कंडीशन क्या है कि नो 2 ऑफ देम शुड बी टुगेदर। तो तुमने यहाँ पे ग्रेटर देन 0 कंडीशन डाल दिया। वो एक्सट्रीम हो भी सकता है, नहीं भी हो सकता है, वो एक्सट्रीम राइट हो भी सकता है, नहीं भी हो सकता है। तो यही तो हो गया ना अरेंजमेंट। ऐसे ही तो तुम 4 बच्चे चूज कर लोगे, सब कुछ ख्याल तो रखा गया। गेटिंग द आइडिया? सो आंसर वुड बी कोई भी 4, नॉट कि आप कोई भी 20C4 करो, 20C4 करने की जरूरत नहीं है। 20C4 में सारे केसेस आ जाएंगे, 20C4 में सारे केसेस आ जाएंगे। यहाँ पे है कि सिर्फ 4 लोगों को सेलेक्ट करना है, ऑलरेडी वो लोग खड़े हैं, उनमें कोई परम्यूटेशन नहीं करना है, इसमें कोई परम्यूटेशन नहीं हो रहा है। वो लोग ऑलरेडी 20 आपको खड़े खड़े ऐसे खड़े हैं सब, ठीक है। अब उनमें से तुमको कोई भी 2 बंदे चूज करने हैं, ठीक है। तो एवरी वन हैज बिकम आइडेंटिकल फॉर मी नाउ, बट आई शुड मेक श्योर कि दोनों के बीच में कोई ना हो, दोनों के बीच में कोई हो, है ना। तो ये तरीका है। क्लियर और नॉट क्लियर? कितने बंदे हैं यहाँ पे? 1 2 3 4 5, ओके। अच्छा, ई में मिस कर गया था क्या? कर लो ठीक। तो 17C4, ठीक है, 17C4, हाँ यही आंसर है, 17C4, ठीक है। समझ में आया कि नहीं आया समझ में? अब यही केस है, ये 20 बंदे लाइन में नहीं सर्कल में खड़े हैं। इसे रब कर दो, ये जो 20 बंदे हैं इन्हें तुम सर्कल में खड़ा कर दो। सर्कल में खड़ा करने के बाद क्या करो? सिमेट्री ब्रेक करने की जरूरत है। मुझे नहीं लगता, ये ऑलरेडी खड़े हैं, ऐसे खड़े हैं 20 बंदे, ठीक है। चलो कोई एक बंदे को चूज कर लो, किसी एक को भी चूज कर सकते हो, ठीक है। फिर उसके बाद 4 चूज हो गए, ये हो गया एक्स ए, ठीक है। नाउ एक्स ए प्लस एक्स बी प्लस एक्स सी प्लस एक्स डी इज 16 and x a all should be positive. 16 minus 4 is 12. So final it will be 12 plus 4 minus 1, that is 15 C3. So I can say 20 C1 into 15 C3. देखो मैं इसमें एक कुछ गड़बड़ काउंटिंग कर दिया था, उसको मैं करेक्ट कर रहा हूं इससे, बताओ क्यों। मैंने उसे करेक्ट बाई डिवाइड बाई 4 क्यों किया। देखो ये 20 लोग खड़े थे, उनमें से किसी एक पे मैंने हाथ रखा कि तुम चलो, तुम तो हो ही। उसके बाद मैंने क्या, उस 20 कोई भी हो सकता था। फिर उसके बाद मैंने ये बोला कि ओके चलो तुम भी आ जाओ, तुम भी आ जाओ, तुम भी आ जाओ। इसको मैंने चूज नहीं किया, सिंपल एक्स ए प्लस एक्स बी प्लस एक्स सी कर दिया, ठीक है। ये कंडीशन डाल दी, ये हो गया। अच्छा मैंने इस पे जब हाथ रखा था 27 में ये भी तो इंक्लूड हो गया था, और ये भी तो इंक्लूड हो गया था, और ये भी तो इंक्लूड हो गया था, तो वो वाला केस ऑलरेडी 4 बार गिन लिया मैं, समझ में आया। So this was the difficult part of every permutation combination. Now we are shifting. I've just got this 25 objective questions for you to discuss. Let's see whether we'll be able to finish. Okay. The first question says, they are very easy questions, I think level 1 questions. The first question reads, total number of 4-digit numbers. How? Okay, I gave you this question, right? Next question. Total number of n-digit number, n greater than 1, having the property that no 2 consecutive digits are same. Huh? See? Why? See, ऐसे बनते चल रहे हैं, नंबर्स बढ़ रहे हैं, ठीक है। ऐसे तुमने फिल करना स्टार्ट किया, यू जस्ट मेड श्योर कि 2 कॉन्सेक्यूटिव साइड सेम ना होने चाहिए, इसकी कॉन्सेक्यूटिव सेम नहीं होने चाहिए, है ना। तुमने पहला बंदे को कितने से फिल करोगे, 9 ऑप्शंस, क्योंकि 0 नहीं डाल सकते हो। इसको कितने तरीके से फिल करोगे, इसको, क्योंकि ये दोनों बस सेम नहीं होना चाहिए, नहीं होना तो डाल ही सकते हो यहाँ पे। फिर अच्छा चलो, ऐसे क्वेश्चन में कभी भी कंफ्यूजन हो, n ग्रेटर देन 1 है ना, तो n इज इक्वल टू 2 कर लो, ठीक है। इसको कितने से फिल करोगे, 81, n इज इक्वल टू 2 के लिए कौन सेटिस्फाई कर रहा है, ये दोनों तो नहीं हो रहा है, नन ऑफ दिस डराता है। तो फिर 3 के लिए भी देख लो, 4 के लिए देख लो, 4 के लिए कंफर्म हो जाए तो हाँ सही है। बट द बेटर वे, वी हैव ऑलरेडी शोन यू द बेस्ट वे, द सर्टेन वे, राइट। एग्जामिनेशन पॉइंट ऑफ व्यू से बता रहा हूँ कि n के क्वेश्चंस को तुम दूसरे तरीके से भी हैंडल कर सकते हो। n की वैल्यू डाल दो, देखो कौन सा ऑप्शन, 2-3 ऑप्शन तो मर जाते हैं, 2 ऑप्शन से फंस जाता है प्रॉब्लम। नीचे आओ, नंबर ऑफ जीरोस एट द एंड ऑफ, we have discussed this question. Okay, come down. Total number of words that can be formed using the alphabets of word Kuber so that no alphabet is repeated in any of the formed word is equal to. See here he doesn't talk about what is the word, मतलब कुबेर से आप सिंगल लेटर वर्ड ही बना सकते हो, 2 लेटर वर्ड भी बना सकते हो। सिंगल लेटर वर्ड कितने बनेंगे, KUBR 5 बनेंगे, ओनली 5 बनेंगे, एक सिंगल लेटर वर्ड, है ना? मीनिंग मतलब नहीं फर्क पड़ता है मीनिंग क्या हो। 2 अल्फाबेट लेटर कैसे करेंगे? 5C2 इंटू 2 फैक्टोरियल, वर्ड बनाने हैं ना, 3 इतने ही बनेंगे। गुड। None of them is no, actually it's, we don't call it alphabet, we call it letter. You know what's the difference between alphabet and letter? What's the difference? No. How many letters have does an English alphabet have? Huh? How many alphabet are there in English language? Only one. That's a set. Alphabet is a set. This set has 26 letters. Okay. So A, B, C, D are not alphabet. It's a letter. And the family of this A, B, C, D till Z is called alphabet. So we have only one alphabet in English language. So यहाँ पे क्वेश्चन था. Okay, ठीक है. ये सबको ऐड कर देना. You'll get the. Okay, please let's interact. When you see 300 factorial, I want number of zeros, means 10 कितने हैं उसमें? So if I say 1 into 2, this is your 300 factorial, right? तो अब सबसे पहले बताओ मुझे 5 के मल्टीपल्स कितने होंगे? 60 होंगे 5 के मल्टीपल्स, ठीक है। 25 के मल्टीपल्स कितने होंगे? 12 होंगे। तो एक तो 25 का 5 ऑलरेडी ऐड हो चुका है। 125 के कितने होंगे? तो टोटल आई हैव गॉट 74 5s. Total how many 5s I have got? 74 5s. And obviously number of 2s is greater than 74. तो 10 कितने हो गए? 10 to the power 74. So 74 zeros. Clear? Okay. So come to fifth question. Total number of 9 digit numbers that are divisible by 5 is equal to. Okay. When you say total number of 9 digit numbers, when you have a divisibility test of 5, you say either it is 5 or 0. Start filling. If it has 5, start filling. It has. So first will be filled by 9, then again 9, then again 9. Sorry, 9 into 10, 10, 10, 10. Getting the idea? 9 into 10 into 10 into 10 into 10, because everything will have 10 options. Clear? So it will be, I think, 18 to the power 18 into 10 to the power 7, right? Got the idea? Can we go up? So this is also easy. Total number of 5 digit numbers having divisible okay 4. तो 4 की divisibility क्या होती है? Last 2 digit. तो एक बार 12 कर दो, बाहर निकाल दोगे, एक बार 16 बाहर निकाल दोगे, एक बार 28 निकाल दोगे, एक बार 36 बाहर निकाल दोगे, बस। क्लियर? ओके, एक बार 32 बाहर निकाल देना, हाँ फिर 68 भी बाहर निकाल देना, फिर 96 भी बाहर निकाल देना। क्लियर? ओके, लास्ट 2 digits should be divisible. So you can say किसको किसको बाहर निकालना? 12 के साथ कर देना, फिर 16 के साथ कर देना, एक के साथ कुछ नहीं होगा, 28 के साथ कर देना, ओके 32 36, वेट 3 के बाद क्या आता है? 6 68 नहीं, 61 62 63 कुछ नहीं होगा, 68 69 नहीं होगा, 8 से क्या हो जाएगा? 8 से भी कुछ नहीं होगा, 92 96। क्लियर? ये सारे केसेस बन गए, इसमें 3 फिल कर देना, आराम से फिल हो जाएगा। ठीक है? कैन वी कम डाउन? Total number of 5 digit number having all the different digit and divisible by 3. व्हेन आई से डिविजिबल बाय 3 सम शुड बी डिविजिबल बाय 3, तो एक तो सिलेक्शन हो गया मेरा 1 2 3, 0 जब नहीं लेंगे तो 5 into दैट इज डिविजिबल, राइट? तो एक तो सिलेक्शन मेरा हो गया 1 2 3 4 5 से, ठीक है। दूसरा सिलेक्शन मेरा होगा, मान लो 0 मैंने ले लिया है, तो 1 2 3 I cannot take it. 1 2 3 5 I cannot take it. नहीं, 1 4 5 0 I can take. What else? बस इतना ही दो ले सकते हैं ना, और कोई नहीं ले सकते। इससे बना देना, शफल कर देना। क्लियर और नॉट क्लियर? वेरी गुड। Total number of ways in which a person can put 8 different rings in the fingers of his right hand. He's talking about fingers, so it's 4. So how to go for it? See, I have 4 fingers and I have 10 different rings, but my fingers are distinct. My fingers are, so मेरे सामने वो रखे हुए हैं अंगूठियां, तो मैंने एक अंगूठी उठाई, उसके पास कितने ऑप्शंस थे? 4। तो पहले अंगूठी के पास 4 ऑप्शंस थे, ठीक है। अब मैंने पहन लिया है यहाँ पे, तो अब मेरे पास दूसरे अंगूठी के पास कितने ऑप्शंस हैं? 3 4 एंड 5। इसके ऊपर भी जा सकता है, इसके नीचे भी जा सकता है। मैं उतार के फिर से उसको डाल दूंगा नीचे की तरफ, है ना, डिस्टिंक्ट है ना। अब मैंने 2 अंगूठी पहन ली है। डोंट वरी कि कैसे पहनेगा, बस देखो कि कैसे मैं डाल रहा हूं, ऊपर से मैं ऐसे डाल दूंगा, वो खुलने वाला अंगूठी है फिर, ठीक है। डोंट वरी कि वो कैसे डालेगा। हाँ, आप देखो 2 अंगूठी मैंने पहन रखी है, कहीं पे भी पहन रखी है, मुझे नहीं पता। नाउ आई विल हैव 6 ऑप्शन। कितनी अंगूठी है मेरे पास? 3 3 6 1 7 11. So if I put 3 factorial, I put 3 factorial, so it becomes 11 factorial by B, 11 P8. Clear? Good. Okay, here comes the interesting one. Now, here comes how to find the divisors. No, I just want to discuss something here now. I want to discuss something. How can you say 588 को प्राइम फैक्टराइज किया? क्या कैसे किया? 2 पे पावर कितना आया? इनटू 3 टू द पावर 1, y टू द पावर, बस इतना ही आया। व्हाट्स द आंसर? 4 into 2 into 2 into 3। ऐसा क्यों किया? हाँ, कैसे कॉम्बिनेशन किया? मतलब ये कैसे, ये मतलब तुमको क्यों आया कि ओके पावर्स को मैं ऐड ऑन करूंगा 3 + 1 1 + 1 1 + 1? फॉर्मूला, लेट्स से एक लड़का है, उसे बाहर घूमने जाना है, ठीक है। उसके पास 5 शर्ट्स हैं, 3 पैंट्स हैं और 2 हैट्स हैं, ठीक है। उस लड़के का नाम सलमान खान है, ठीक है। तो सलमान खान जो है वो शर्ट के बिना भी जाता है ना कभी कभी। सो हाउ मेनी ऑप्शन सलमान हैज टू वेयर दिस शर्ट? 6। पैंट्स के लिए 3 एंड हैट्स के लिए 3, whether he wants to wear a hat or not, right? So total कितने तरीके से बाहर जा सकता है वो? 6 into 3 into 3, right? This is the way we calculate things. Stages में हम लोग मल्टीप्लाई करते हैं। Now अब तुम्हारा ये जो नंबर है 588 का जो डिवाइजर है, it will be of the form 2 to the power 3 into 3 to the power q into 5 to the power r into 7 to the power s always will be in the form of, right? Now P Q R S, ठीक है। अब देखो मेरा जो भी फैक्टर आएगा उसमें 2 हो भी सकता है, नहीं भी हो सकता है। तो 2 के पास कितने ऑप्शंस हैं? P प्लस 1। 3 के पास कितने ऑप्शंस हैं? ठीक है, ये तो हो गया टोटल नंबर ऑफ फैक्टर्स when 1 is also included and the number itself is also included. Now my question, नहीं वो इंक्लूड हो गया। अगर क्या कहते तुम्हें वो उसको इंक्लूड नहीं करना तो -1 या -2 है ना। जब अगर 1 इंक्लूड नहीं करना तो -1 और अगर द नंबर इटसेल्फ भी इंक्लूड नहीं करना तो -2। क्लियर? नाउ माय क्वेश्चन इज फाइंड द टोटल नंबर ऑफ इवन फैक्टर्स। इवन फैक्टर्स मतलब यू नीड P2, तो P प्लस 1 मतलब नहीं होगा, P होगा, शर्ट पहन के ही जाना है, ठीक है। नाउ Q प्लस 1, R प्लस 1, S प्लस 1, ये क्या हो गया? इवन फैक्टर्स। नाउ लेट्स से ऑड फैक्टर्स। ऑड मतलब मुझे ये नहीं, शर्ट नहीं पहनना है, ठीक है। सो ये हो गया 1, राइट। ये सब स्टेजेस है, सो इट विल ऑल मल्टीप्लाई। लेट्स से आई हैव टू फाइंड द नंबर व्हिच आर मल्टीपल ऑफ 3, तो इस पे फर्क नहीं पड़ेगा 3 का मल्टीपल, तो ये हो जाएगा P प्लस 1, ये हो जाएगा Q, ये हो जाएगा R प्लस 1, ये हो जाएगा S प्लस 1। क्लियर? इफ आई हैव टू फाइंड मल्टीपल ऑफ 5, इस पे फर्क नहीं पड़ेगा P प्लस 1, इस पे फर्क नहीं पड़ेगा Q प्लस 1, R, इस पे फर्क पड़ेगा तो R मैंने डाल दिया है ना। नाउ लेट्स से 3 एंड 5, 3 एंड 5 मतलब शर्ट भी पैंट भी, तो Q और R, और इसमें फर्क नहीं पड़ेगा। क्लियर? एंड व्हेन 3 और 5, तो क्या करेंगे? दिस प्लस दिस माइनस दिस। क्लियर और नॉट क्लियर? तब डिवाइजर से क्वेश्चन जब भी आएंगे डरने का नहीं है। थिंक ऑफ सलमान खान। ओके नाउ इवन का ये है, ये टोटल का है, ऑड का है, ये इवन का है। टोटल, थैंक गॉड आई रिमेंबर द ऑर्डर। क्लियर? ऑड वाला नहीं समझ में आया? ऑड वाले में मतलब 2 आपको मतलब क्या कहते हैं, आपको 2 चाहिए ही नहीं, तभी ना ऑड बनेगा। एक भी 2 आ गया तो ऑड नहीं हुआ। 0 2 to the power 0 is 1 ना, मतलब 0 ऑप्शन। आई एम नॉट वेयरिंग अ शर्ट इज आल्सो अ काइंड ऑफ टाइप ना। सलमान खान इज नॉट वेयरिंग अ शर्ट, तो हम लोग 5 शर्ट्स थे उसके पास, तो टोटल शर्ट्स उसके पास कितने वे से वो शर्ट पहना था? 6 वे। या तो रेड शर्ट पहनेगा, येलो या ब्लू या ग्रीन या ऑरेंज, या शर्ट नहीं पहनेगा। तो यहाँ पे वो शर्ट नहीं पहन रहा है आज, ठीक है, तो वो भी तो एक तरीका है। क्लियर? समझ में आया ये? नाउ सी टोटल नंबर ऑफ डिवाइसेस ऑफ 480 दैट आर ऑफ द फॉर्म। अच्छा सेम क्वेश्चन है, देखो इसने क्वेश्चन को ट्विस्ट किया है, तो अब वो फॉर्मूला तुम्हारा फ्लॉप कर रहा है। 480 किस फॉर्म में चाहिए तुम्हें? 4n प्लस 2। 4n प्लस 2 क्या होता है? 2n प्लस 1 इंटू 2। यू ओनली वॉन्ट 1 2, इसमें फिक्स कर दिया है तुमने इसको। ये उसके बाद इस पे ऐसा तुम प्ले ऑन कर सकते हो, तो तुमने P को 1 बना दिया है और बाकी सबके साथ प्ले ऑन किया है। समझ में आया कि नहीं समझ में आया? नहीं समझ में आया? आ गया ना? गुड। कैन यू गो टू द नेक्स्ट स्लाइड? ये क्वेश्चन शायद मैंने दिया था, यू हैव सॉल्व्ड इट। कैन वी गो डाउन? ओके, पता नहीं, देख लेंगे। Total number of words that can be formed using all the letters of British that neither begins with I nor ends with B is equal to, पहले तो विदाउट रिस्ट्रिक्शंस निकाल दो, फिर I से शुरू कर दो, B से एंड कर दो, और ठीक है माइनस नीचे ये कि अंशुमन में कितने लाइक सेम चीजें हैं? 2a है, 2n है, और बाकी सब डिफरेंट है. ANSHUM, ये तो पहला क्वेश्चन है यार जो शुरू में हमने बात की थी. I got A and I got N and N. So I see how many? 1 2 3 4 5 6 7 8 3 3 6 2 8. शुरू में हमने सबको डिस्टिंक्ट मान लिया तो 8 फैक्टोरियल से शफल किया, और ए को शफल करने से कोई फर्क नहीं पड़ता है, और बी को शफल करने से, एन को शफल करने से कोई फर्क नहीं पड़ता है. कैन वी कम टू 12th क्वेश्चन नंबर? ओके, डन. 13. How to solve this question? NC2 minus N. Perfect. क्योंकि आप कोई भी पॉलीगॉन में टोटल साइड्स कितने बन सकते हैं? NC2. और n साइड्स के पॉलीगॉन में साइड्स कितने होते हैं? n. तो ऑब्वियसली अदर देन एनी लाइन अदर देन साइड्स आर डायगोनल्स. कैन वी कम डाउन? This is my 5th hour running in which I am speaking continuously. So I am now, I think, low energy. Red alarm. You play the game, not energy. Okay, library has A copies of 1 book, B copies each of 2 books, C copies each of 3 books, and single copy of D books. वही simple कहानी है. Total books है A plus 2B plus 3C plus D, और जो सिमिलर्स हैं उसके साथ शफल कर देना. नेक्स्ट, आप लोग ये सब क्वेश्चंस आप लोगों को मिल जाएगा, प्लीज आप लोग सबको प्रैक्टिस करना. नेक्स्ट क्वेश्चन. एवरीबॉडी इन अ रूम. अच्छा, हैंडशेक. Everybody in a room shakes hand with everybody else. The total number of handshake is 153. The total number of NC2 is equal to 153. That's it. Can we come down? वही क्वेश्चन है ना? उसमें कोई कंडीशन तो नहीं दे रखा था कि वो उससे नहीं मिलाएगा, वो उससे नहीं मिलाएगा. नहीं. The total number of the number of numbers that are less than 1000 that can be formed using the digit 0 1 2 3 4 such that no digit is being repeated in the formed number is equal to. पहले तो सिंगल डिजिट बना दो. तो 0 को इंक्लूड करना है कि नहीं करना है? करेंगे शायद. 0 is the number which we need to include, right? तो सिंगल डिजिट कितने हो गए? 6. देखो एग्जाम में बड़ा डाइसी होता है ये सारी चीजें, 0 इंक्लूड करना है कि नहीं यहाँ पे, बट जो बेस्ट चीजें हैं वो कर लो, मान लो, क्योंकि 0 is also a number which is lesser than 1000, right? तो 0 will be included. तो पहला तो सिंगल डिजिट कितने बनेंगे? 6. 2 डिजिट कितने बनेंगे? हाँ, 5 into 5 है ना? 5 into 5. I don't want the digit to be repeated, right? और फिर उसके बाद वो भी बना लेना 3 और टोटल ऐड कर देना. कैन वी कम डाउन? देखो यहाँ पे कंफ्यूजन छोड़ा है, 0 लेना है कि नहीं. अब एक मिनट ऊपर जाइएगा. 130 131 155 156 एक का पंगा दिया है. कैन यू कम डाउन? तो जब भी ऐसा हो, always consider the basic fact that 0 is a number. I will include it. Whether if you are going to not consider my answer, I am always going to add it on. क्योंकि अगर 0 को consider नहीं करना होगा तो they will explicitly write it. Okay. Total number of 6-digit numbers that can be formed having the property that every succeeding digit is greater than preceding digit. Succeeding digit क्या होता है? जो पहले आता है. सक्सीडिंग बाद में आता है, प्रीसीडिंग पहले आता है ना? तो इस टाइप से लिखा हुआ है. कितने नंबर्स हैं? एंड स्टोरी ये है ना? मतलब ये सबसे छोटा होगा. 0 तो कभी हो नहीं सकता है. जब ये 0 नहीं हो सकता तो इधर भी कभी 0 नहीं होगा. तो 0 की कहानी है ही नहीं. तो यहां कितने ऑप्शंस डाल सकता हूं मैं? क्लियर और नॉट क्लियर? गुड. Can we come down? N1 men and N2 women are to be seated in a row such that no two women sit together. If N1 is मतलब मर्द ज्यादा हैं औरत कम है, और पहले आप मर्द को बैठाइए, जो भी ज्यादा होते हैं उन्हें पहले बैठा दिया जाता है, जितने स्पेस बचते हैं उसमें दो सेलेक्ट करके डाल दो और फिर शफल कर दो. गुड, यू कैन हैंडल इट. कैन वी कम डाउन? देयर आर n नंबर सीट्स अराउंड अ राउंड टेबल. इसमें सिमेट्री है कि नहीं है? नहीं है. They are numbered. They will be treated simply like a linear thing. Okay. There are n numbered seats around a round table. Total number of ways in which n1 person can sit around the table is equal to. Very easy. NC n1. ये actually वही check कर रहा था. Round table से तुम actually understand करते हो कि नहीं symmetry or not symmetry. ठीक है. These are the basic questions, but actually difficult. If they are just testing your basic concepts. Can you come down? Total number of ways in which 4 boys and 4 girls can be seated around a round table so that no two girls sit together. पहले बॉयज को बैठा दो और फिर उनके बीच में गर्ल्स को बैठा दो. तो बॉयज को तुम कैसे बैठाओगे? 3 फैक्टोरियल से कितने बचने हैं? 4 बॉयज है ना, तो 3 फैक्टोरियल से तुमने 1 मिनट 4 बॉयज नो टू गर्ल्स सिट टुगेदर, तो आपने 3 factorial into 4 factorial. ठीक है? Clear? Can we come down? 3 boys of class 10, 4 boys of class 11 and 5 boys of class 12 sit in a row. Total number of ways in which this boy can sit so that all the boys of same class sit together. ठीक है? आराम से हैंडल हो जाएगा. Can we come down? Total number of ways in which the letter of the word Mississippi be arranged so that any two S's are separated. ठीक है? You can handle it. Can you come down? The number of ways in which a mixed double game, mixed double, आपको सिर्फ एक ही गेम खिलाना है, be arranged among 9 married couples so that no husband and his wife play in the same game. तो मतलब है आपके पास 9 couples हैं, तो आप सबसे पहले 9 हस्बैंड को चूज, 9 में से 2 हस्बैंड चूज कर लो, 9C2. उसके बाद आपके पास कितने वाइफ्स बचे हैं जो आप शेयर मतलब चूज कर सकते हैं? 7C2. उसके बाद आपको पता है कि आपने लेट से M1 M2 को चूज किया था और यहाँ पे W3 W4 को चूज किया था, तो आप कितने तरीके से गेम करा सकते हो? एक गेम में हो सकता है M1 M3 ये पेयर बन सकते हैं या 2. तो फाइनल आंसर भी क्लियर? ठीक है, बी हो जाएगा. Now 24th, a candidate is required to answer 7 out of 10 questions which are divided into 2 groups, each containing 5 questions. He is not permitted to attempt more than 4 questions from each group. Total number of different ways in which the candidate answer the paper. पहले तो सेक्शन चूज करेगा, किससे? उसको 4 चूज करना है. ठीक है, तो उसको कैसे चूज करेगा? वो 2 तरीके से चूज कर लिया, 2C1. उसके बाद उसमें से वो 3 क्वेश्चन अटेम्प्ट करेगा, उसके बाद 4 क्वेश्चन अटेम्प्ट करेगा. लेकिन इस क्वेश्चन में देखो क्या है, टोटल नंबर डिफरेंस इन विच द कैंडिडेट कैन आंसर द पेपर, है ना. अब देखो इसमें जो 3 क्वेश्चन चूज किया है उसके ऑर्डर भी इंपॉर्टेंट है, क्योंकि वो उसके हाउ ही इज आंसरिंग इट. तो इसको 3 फैक्टोरियल से कर सकता है और इसको देख लेना, पीवी में जो आंसर आ जाएगा वो आ जाएगा. ठीक है, कैन यू कम डाउन? Total number of ways in which 22 different books can be given to 5 students so that 2 students get 5 books each and all the remaining students get 4 book each. क्या करें? Don't see the options. आप ऐसे बताओ ना क्या कहानी हो रही है. 22 different chocolates, 22 distinct chocolates in 5 distinct boxes in the ratio and you know how to take care of it. 3 factorial और 2 factorial से नीचे divide कर देना, ठीक है? Clear? So we couldn't interact with the person who wanted to have a video interaction, and we finally finished this permutation combination. Sorry, we couldn't manage the time for binomial or anything of the sequential part, right? So probably, what's the answer of question number 20? It's 3 factorial into 4 factorial. Or please attempt all the 25 questions. Please, PDF, I will ask ma'am to provide you the PDFs, okay, to all the centers as well, so that you can have the all interaction together caught up in the book, so that you can any day brush up things. Things will be very clear to you, right? Which question? How many 4-letter word can be word from the word proportion? Since I can see 2p, 3o, double r, and rest are single, right? I have to create 4-letter words. 4-letter words, huh? So 4 like तो possible नहीं है. I'll break the things into the cases. 3 like, 1 distinct, 2 like, 2 like, 2 like, 2 distinct, when I am choosing all distinct, I have how many options? P, 3p, 3o, 2r, 1t, 1i, 1n. So I have 1, 2, 3, 4, 5, 6. 6c4 into 4 factorial. These are the words. All factorials ka. I just want to choose 2 like. 2 like. This 3 can provide me 2 like. So I just have to do 3c1 into, I'll have rest 5 c2 into 4 factorial by 2 factorial. Now only these 3 has the capacity to give me 2 double likes. So I can say 3c2, and for 3 like and 1 distinct, I have only these 2 has the capability. Now rest 5 can give me the another fellow. Clear? Any more question? So, and that's 3. Okay. Bye bye then.